Standing before the Great Pyramid of Giza, it's almost impossible not to feel a profound sense of awe. The sheer scale of it, the breathtaking precision of its construction, it all seems to defy the very logic of the ancient world we think we know. We've been told a familiar story, one of tens of thousands of workers toiling for decades, using nothing more than copper tools, ropes, and ramps. But what if that story, as comforting and established as it might be, is incomplete? What if the truth behind these monumental achievements points to a chapter of human history far more sophisticated and far more mysterious than our textbooks have ever dared to suggest? This is the powerful, tantalizing question that has captivated explorers, engineers, and historians for generations. Could the ancient Egyptians have possessed technology far more advanced than we've ever given them credit for? We're not talking about magic or alien intervention, but rather a forgotten epoch of human ingenuity, a level of technical skill and scientific understanding that seems to vanish from the historical record, only leaving behind its incredible stone-cut fingerprints. From granite boxes carved with a precision that rivals modern machinery, to temple walls depicting what appear to be complex electrical devices, the clues are scattered all across Egypt, waiting for anyone willing to look with fresh eyes. This journey we're about to take together will explore 30 distinct pieces of evidence, each one a compelling piece of a larger, startling puzzle. We will examine these artifacts and architectural marvels not with skepticism meant to dismiss, but with a spirit of open-minded inquiry. Our mission is to piece together a different narrative of the past, one that challenges the conventional timeline and invites you to reconsider everything you thought you knew about ancient human capabilities. So prepare to look at familiar landmarks in an entirely new light, as we delve into the mysteries and uncover the secrets that have been hiding in plain sight for thousands of years. Our journey into the evidence begins with the very structure that defines this mystery, the Great Pyramid itself. The first and perhaps most overwhelming clue isn't found in a hidden chamber or a cryptic inscription, but in the breathtaking precision of its core construction. We're often impressed by its size, but the real wonder lies in the microscopic details and the astronomical alignment that modern engineers struggle to explain. Let's start with its position on the planet. The Great Pyramid is aligned to true north with an accuracy that is simply staggering. Its base is oriented within a mere 3/60ths of a single degree of perfect cardinal alignment. To put that into perspective, our own Paris Observatory, built in the late 17th century, is misaligned by a larger margin. Achieving this level of precision over a base covering 13 acres without satellites, GPS, or even the magnetic compass, which wouldn't be invented for another 2,000 years, presents a profound enigma. It suggests the ancient builders possessed a sophisticated understanding of celestial cycles and terrestrial surveying that we have yet to fully comprehend. This obsession with accuracy extends down to the very stones. The outer casing blocks, now mostly gone, were once fitted together with joints so tight that a razor blade cannot be inserted between them. We're not talking about rough, irregular stones piled high. These were finely milled blocks of Tura limestone, polished to a brilliant white, assembled with a precision that rivals modern optical engineering. The effort required to achieve such seamless fits across thousands of blocks goes far beyond what we would expect from a society reliant solely on copper chisels and stone hammers. It implies the use of advanced machining techniques or a lost method for cutting and polishing stone to near-perfect flatness, a technology that seems to disappear from the historical record after the pyramid's completion. Then we have the mathematical intelligence literally built into the pyramid's form. The ratio of its perimeter to its height equates to 2 times pi, a mathematical constant that wasn't officially calculated in the Western world for another 3,000 years. This isn't a vague approximation, it's a precise relationship encoded in stone. Furthermore, the dimensions of the king's chamber incorporate another advanced mathematical concept, the Pythagorean theorem, centuries before Pythagoras was born. These are not coincidences, they are the fingerprints of a highly developed scientific understanding, a system of knowledge that integrated geometry, astronomy, and geophysics into a single monumental project. When you stand back and consider all these factors together, the celestial alignment, the machined stonework, and the encoded mathematics, the traditional explanation of tens of thousands of workers dragging blocks up mud ramps begins to feel insufficient. It points toward a civilization that had mastered its environment through a science we are only just beginning to recognize. Yet for all the mathematical and astronomical genius encoded within the Great Pyramid, perhaps an even more tangible and baffling piece of evidence lies underground, just 20 miles to the south, at the ancient necropolis of Saqqara. Here, deep within a network of tunnels known as the Serapeum, we encounter our second compelling piece of the puzzle, a collection of massive granite boxes that defy conventional explanation. These are not simple burial containers, they are 24 colossal sarcophagi, each carved from a single, solid block of Aswan rose granite, a material renowned for its extreme hardness. Weighing in at around 100 tons each, with lids alone estimated at 30 tons, their mere transportation and placement underground is a logistical nightmare to consider. But the true mystery isn't their immense weight, it's the almost supernatural precision with which they were crafted. When you stand in front of one of these gigantic boxes, the first thing that strikes you is the immaculate, mirror-like finish on the outside surfaces. This isn't a rough, hand-chiseled texture. The granite has been worked to an astonishing degree of flatness, with surfaces so perfectly level and right-angle corners so exact that modern engineers have measured their accuracy to within a few thousandths of an inch across their entire length and width. To achieve this kind of precision on any material would be impressive, but to accomplish it on granite, a stone harder than steel using only the simple copper chisels, stone dolerite balls, and wooden wedges that mainstream Egyptology attributes to the ancient builders, is functionally impossible. Copper is a soft metal. It would barely scratch the surface of this granite, let alone allow a worker to precisely mill it down to a flawless optical grade plane. The interior of these boxes presents an even greater challenge. Many feature complex, curved undercuts and internal corners that are seamlessly blended, with no tool marks to indicate how such a shape could have been hollowed out from a solid block. This level of craftsmanship suggests the use of tools that could apply tremendous, consistent force and cut with a fixed, unerring path, the kind of work we achieve today with computer-controlled, diamond-tipped milling machines. The presence of what appear to be precise drill holes in the granite further cements this theory. The spiral grooves found inside some of these ancient bores indicate a feed rate and pressure that would be consistent with a powered drill bit, not a manual hand-cranked tool. The inescapable conclusion is that whoever created these artifacts possessed a technology capable of cutting and polishing granite as if it were butter, a level of machining expertise that simply does not fit within the standard timeline of human technological development. These silent, polished boxes stand as a direct physical challenge to our understanding of the past, forcing us to ask what tools truly existed in the workshops of ancient Egypt. Moving from the immense, perfectly crafted boxes of the Serapeum, our investigation leads us to an artifact that is small enough to hold in your hand, yet it carries implications just as colossal. This is our third piece of evidence, and it comes not from a grand chamber, but from the collection of the Petrie Museum in London. Here resides a core sample, labeled UC16000, drilled from a block of Aswan granite. To the untrained eye, it might look like a simple, weathered stone cylinder, but to an engineer or a machinist, this object is nothing short of revolutionary. It tells a story of a technology so advanced that it directly contradicts the standard narrative of ancient Egyptian toolmaking. The core itself was extracted with a tubular drill, and the spiral groove running along its length is the key to the entire mystery. This isn't a rough, irregular scratch. It's a consistent, continuous groove that spirals around the core with a remarkably even depth and pitch. The pattern it reveals is absolutely critical. It demonstrates that the drill bit that created this core fed into the incredibly hard granite at a constant, unvarying rate. Think about what that means in practical terms. To achieve this, the drill couldn't be wavering or being pushed by hand with inconsistent human force. The pressure applied had to be immense and perfectly steady, the kind of consistent thrust we associate today with a machine-powered drill press. The feed rate, the speed at which the drill advanced into the stone, was so uniform that modern engineers who have studied it have stated it would be difficult to replicate even with contemporary machinery. This single piece of granite tells us that the ancient drill didn't just spin. It bit into the stone with a relentless mechanical precision that human muscle power simply cannot sustain. Now consider the material. Granite is one of the hardest stones on Earth, significantly harder than the copper tools the Egyptians are supposed to have used. A copper drill tip would have dulled to nothing in seconds against this rock. The mere fact that they were drilling into it so effectively implies they possessed drill bits made of a material harder than granite, perhaps tipped with diamonds or another abrasive compound. But the material is only half the puzzle. The even feed rate points to something even more sophisticated, a mechanical system for applying force. This wasn't a handful of workers leaning on a bow drill. The technology required suggests a heavy, stable apparatus capable of applying tons of downward pressure while simultaneously rotating the drill shaft at a high, consistent speed. Some researchers have proposed the use of a weighted lever system or even a form of ancient counterweight, but the precision of the groove suggests a level of engineering finesse that goes far beyond simple weight and pulley systems. This core sample is a fossilized moment in time, a perfect impression of a tool in motion that whispers of lost industrial knowledge. It stands as a direct physical challenge, forcing us to rewrite the history of technology and acknowledge that the ancient world may have hummed with the sound of machinery we are only now beginning to understand. But the evidence for this lost high technology is not confined to deep tunnels or museum drawers. It is proudly on display, built into the very foundations of the Giza plateau itself. Our fourth piece of evidence takes us to the Valley Temple of Khafre, a structure that stands in the shadow of the second pyramid. At first glance, it might seem less impressive than its colossal neighbors, but a closer look at its construction reveals a stone-cutting prowess that is, in many ways, even more bewildering than the pyramids. Here, the builders worked with immense blocks of granite, some weighing over 150 tons, and assembled them with a technique that seems to belong to a much later industrial age. The true marvel of the Valley Temple lies in the joints between these gigantic stones. We are not looking at simple, stacked blocks. The builders employed a method of complex, interlocking masonry. Massive blocks were carved with protrusions that fit perfectly into corresponding recesses in the adjacent stone, like a gigantic, three-dimensional stone puzzle. This kind of joinery does more than just hold the wall together. It creates a structure that is incredibly resistant to seismic activity and lateral shifting. The precision required to carve these intricate, load-bearing shapes out of granite, one of the most difficult stones to work with, is almost beyond comprehension. It suggests the builders weren't just stacking rocks, they were engineering with stone on a molecular level, treating it like a modern architect would treat pre-stressed concrete. Now consider the internal corners. Inside some of the temple's chambers and within the puzzle piece joints themselves, you find perfect 90-degree internal corners. To understand why this is so significant, try to imagine carving a perfect square hole into a block of solid wood using only a dull chisel and a hammer. It would be nearly impossible to get that sharp, crisp internal corner. Now translate that challenge to granite, a material far harder than steel. How do you achieve a flawlessly sharp 90-degree corner inside a solid block of granite without advanced saws or milling tools? The traditional explanation of pounding away with dolerite balls would only create rounded, uneven hollows, not the machined, razor-sharp internal angles we observe. This level of precision implies the use of a technology that could make straight, repeated cuts with immense force and stability, something akin to a massive, straight-line saw, perhaps embedded with industrial diamonds or another super-hard abrasive, capable of sliding through granite as if it were soft wood. The sheer scale of the blocks only deepens the mystery. We are dealing with stones that weigh as much as a small locomotive. The process of quarrying them, transporting them, and then lifting them into place is a phenomenal achievement in itself. But to then perform such delicate, precise carving on these behemoths, shaping their complex joints and internal geometries with micrometer accuracy, points to a level of control that goes far beyond brute force. It suggests the ancient stonemasons had mastered their material completely. They could not only move mountains of stone but could also sculpt them with the finesse of a master jeweler. The Valley Temple, therefore, stands not just as a religious monument, but as a permanent, open-air museum exhibit showcasing a stone-working technology that remains, in many respects, lost to us today. It forces us to question not just how they built, but what knowledge truly vanished when their civilization declined. Now, while our primary focus remains on the sands of Egypt, sometimes the most compelling evidence for a technologically advanced ancient world comes from looking at the bigger picture. To truly understand the context of what might have been possible, we must occasionally glance at the artifacts left by neighboring civilizations. This brings us to our fifth piece of evidence, a fascinating object discovered not in Giza, but in the sands of Mesopotamia, in a place we now call Qujat Rabu, just outside Baghdad. It's a humble-looking artifact dated to the Parthian period around 2,000 years ago, and it has sparked one of the most electrifying debates in archaeology. It's known as the Baghdad Battery. The object itself is deceptively simple. It consists of a 13-centimeter tall clay jar, inside of which sits a rolled copper sheet forming a cylinder. This cylinder is sealed at the top with an asphalt plug, and through the center of this plug runs an iron rod, suspended perfectly down into the middle of the copper cylinder without touching its sides. If you were to look at this collection of parts, a clay pot, a copper tube, and an iron rod, you might see nothing more than a peculiar ancient container for a scroll or a religious offering. But to anyone with a basic understanding of electrochemistry, its design is stunningly familiar. This is the fundamental structure of a simple galvanic cell. If this jar was filled with an acidic electrolyte, something as common as vinegar or grape juice, a chemical reaction would occur. The acidic liquid would act as an electrolyte, allowing electrons to flow from the iron rod to the copper cylinder. The result, a measurable electrical potential difference of about 1 volt, would be generated between the two metals. So, the inevitable question arises, what could an ancient civilization possibly do with 1 volt of electricity? On its own, a single cell is not particularly powerful. It won't light up a city or power a machine. However, the theories proposed are as intriguing as the object itself. One of the most compelling suggestions is that it could have been used for electroplating, the process of using an electric current to deposit a thin layer of a precious metal, like gold, onto the surface of a less valuable object such as silver or copper. We have numerous examples of ancient artifacts from Mesopotamia to Egypt that are covered in remarkably thin, uniform layers of gold. The conventional explanation for this is fire gilding, a dangerous process involving mercury. But the electroplating theory offers a cleaner, more precise alternative. A series of these batteries, connected together to create a higher voltage, could have provided a steady, controllable current to achieve this effect. Imagine an ancient artisan's workshop, not with soot and fire, but with rows of these clay pots, silently electroplating a statue or a piece of jewelry with a perfect microscopic layer of gold. Of course, mainstream skepticism exists. Many archaeologists argue that these jars were simply used for storing sacred scrolls, and the coincidence of their electrochemical potential is just that, a coincidence. They point out that no wires have been found with them, and that the asphalt seal could have just been a practical way to keep the contents dry, but this counter-argument feels incomplete. Why go through the trouble of crafting such a specific assembly? Why use an iron rod suspended in a copper cylinder sealed with bitumen, a material known for its excellent insulating properties, if the goal was merely storage? The components seem too perfectly chosen for their electrochemical properties to be entirely accidental. The existence of the Baghdad battery, even as a singular, controversial find, forces us to expand our imagination. It suggests that the spark of electrical knowledge may not have been a sudden invention of the 18th century, but perhaps a flame that was discovered, utilized, and then lost, flickering in ancient workshops across different cultures. This single, unassuming clay pot hints that the technological landscape of the ancient world might have been far more dynamic, interconnected, and sophisticated than our history books have led us to believe. And so we move from a physical object that could generate electricity to ancient stone walls that seem to depict its practical application. Our sixth piece of evidence transports us to the Hathor Temple at Dendera, a site that holds one of the most visually striking and hotly debated enigmas in all of Egypt. Carved onto the walls of a hidden crypt are a series of bizarre and unique reliefs. To the modern eye, they present an uncanny, almost unmistakable image. They look like massive, archaic light bulbs. Within a large, transparent, pear-shaped vessel, you can see a snake-like form stretching along its length, curling inward at the tail. This filament is held in place at its base by what appears to be a supporting stand, and at its tip, it connects to a cable that leads to a small box upon which a kneeling figure is resting. The entire assembly is supported by a tall, pillar-like object that many researchers identify as a djed pillar, a symbol we know represents stability and strength, but which, in this specific context, bears a striking resemblance to a high-voltage insulator. The composition is so coherent and so mechanically logical that it's difficult to unsee the comparison. You have a bulbous envelope, an internal filament connecting wires, and an insulated support structure. It's a complete system. The mainstream Egyptological interpretation offers a very different, purely symbolic reading. Scholars explain that this is a representation of a foundational creation myth. The bulb is actually the womb of the sky goddess Nut. The filament is a snake, a symbol of fertility and regeneration emerging from a lotus flower, which is the base. The djed pillar symbolizes stability, and the entire scene depicts the cosmic cycle of birth and rebirth, the snake traveling through the womb of the sky to be born anew. This is a valid and well-documented mythological framework. However, the controversy arises when we confront a very practical, logistical problem faced by the ancient builders themselves: illumination. How did the artists who carved these incredibly detailed and precise reliefs deep inside windowless, pitch-black tombs and temples actually see what they were doing? The traditional answer is simple: they used torches and oil lamps, but when you test this theory in practice, it quickly falls apart. Burning torches and simple lamps produce soot, smoke, and flickering, unstable light. They consume oxygen and would have made working in deep, confined, and poorly ventilated spaces unbearable over long periods. More critically, they leave behind undeniable evidence. If every temple wall and tomb chamber in Egypt was decorated by artists relying on open flames, we would expect to find vast accumulations of soot coating the ceilings and upper walls. Yet, in many of these places, like the intricate corridors of the Valley of the Kings or the perfectly painted chambers deep within the Great Pyramid, The ceilings are often pristine, free of the carbon deposits that are the inevitable byproduct of torchlight. This presents a profound mystery. What source of clean, bright, and steady light did they use to execute artwork of such finesse in total subterranean darkness? The reliefs at Dendera offer a tantalizing, if speculative, answer. Could they be a symbolic representation of a real, functional technology? Perhaps the priests of Hathor, seeking to describe a device they didn't fully understand, used the symbolic language they knew best. They might have depicted an electrical light, a technology we would only reinvent millennia later, using the iconography of snakes, lotuses, and jade pillars. The snake, writhing with energy, becomes a perfect symbol for a glowing, arcing filament. The insulating jade pillar, a symbol of enduring power, becomes the physical support for this miraculous serpent of light. This isn't to say the Egyptians had a modern electrical grid, but it does force us to consider the possibility that they had discovered and harnessed a principle, perhaps a form of geophysical energy or arc lighting, that allowed them to produce a brilliant, flameless light. The Dendera carvings, therefore, stand at the crossroads of myth and technology. They challenge us to look beyond a literal or purely symbolic interpretation and consider that these ancient artists may have been recording something extraordinary, leaving behind a stone-cold blueprint for a technology that would one day light up the world. From the symbolic carvings of potential ancient light at Dendera, we journey south, up the Nile River to the sun-scorched quarries of Aswan. Here lies our seventh piece of evidence, a testimony not of a finished masterpiece, but of a colossal failure, an artifact that reveals more about the methods of its creation than any polished monument ever could. This is the unfinished obelisk still lying in its granite bed, attached to the living bedrock. It is a behemoth of stone that, if completed, would have stood over 130 feet tall and weighed a staggering 1,200 tons. Its very presence is a lesson in ambition, but the true secret it holds is etched into the stone surrounding it, a network of perfectly straight, parallel channels and trenches that defy simple explanation. When you stand at the edge of this quarry and look down, the scale is almost incomprehensible. Workers were attempting to free a single piece of stone taller than a 10-story building from the planet itself. The initial stages of this process are visible and, to some extent, understandable. They began by carving a perimeter trench around the intended obelisk, just wide enough for a person to stand in. The conventional explanation is that teams of workers would then squat in these trenches, relentlessly pounding at the granite with dolerite balls, a stone harder than granite, to slowly, laboriously pulverize the rock bit by bit. This method, in theory, could eventually carve out a trench, but when you examine the trenches around the unfinished obelisk and elsewhere in the Aswan quarries, you encounter a problem of precision that challenges this entire narrative. The sides of these trenches are not rough, uneven surfaces you would expect from a chaotic process of pounding with stone balls. Instead, they are often remarkably smooth and, most tellingly, perfectly parallel to one another. The channels run straight for dozens of feet, maintaining a consistent width and depth with clean, sharp corners at the junctions. This is not the work of random pounding. This is the signature of a guided, controlled cutting process. Imagine trying to carve a perfectly straight, foot-deep channel into a block of solid concrete using only a sledgehammer. No matter how careful you were, the result would be a jagged, irregular trough. To achieve the kind of parallel, planar surfaces we see in Aswan with nothing but hand-held pounding stones is a practical impossibility. The precision implies the use of a tool that could make a continuous, straight cut, a tool that moved along a fixed path, removing material in a uniform way. This brings us to the core of the mystery. What technology could have allowed the ancient quarry workers to slice through granite as if it were cheese? The sheer efficiency required to undertake a project of this scale is another critical clue. The idea of pulverizing enough granite to free a 1,200-ton obelisk using nothing but muscle power and stone hammers is a logistical nightmare that would have required an unimaginable amount of time and labor. The evidence at the quarry suggests a different, far more advanced approach. Some researchers propose the use of massive, straight-line saws. These wouldn't be saws with teeth, but rather long, flat blades of copper or another material, pulled back and forth while an abrasive slurry of sand and water was poured into the cut. While this is a more plausible theory than pounding stones, it still faces challenges. To cut through a swan granite, a saw would need to be incredibly long and strong, and the downward pressure required would be enormous. The perfectly parallel sides of the trenches suggest the saw, or whatever tool was used, was held in a rigid, stable frame, preventing it from wobbling or deviating from its path, the hallmark of a machine-like apparatus, not a team of men pulling on a rope. Another compelling theory involves the use of a different, lost method altogether. Could the ancients have possessed a chemical or thermal technology that softened the granite, allowing it to be worked more easily? While there is no direct evidence for this, the precision of the cuts forces us to consider all possibilities. The trenches at Aswan do not look like the result of brute force, they look engineered. They are the kind of clean, efficient cut you would expect from a modern quarry that uses diamond wire saws, a technology where a cable embedded with industrial diamonds is pulled through the rock, cutting it with incredible speed and precision. The parallel channels in Aswan are a fossilized imprint of a process that was similarly effective. The unfinished obelisk, therefore, is far more than an abandoned project. It is an open-air laboratory, a frozen moment that captures a high-technology quarrying process in mid-action. It shows us that the ancient Egyptians didn't just struggle with stone, they mastered it, employing methods of extraction so efficient and precise that they remain, in many ways, a secret locked in the red granite of Aswan. Yet, the evidence for this lost technology extends far beyond the age of the pyramids, reaching back into the very dawn of Egyptian civilization. Our eighth piece of evidence takes us into the shadowy pre-dynastic era, a time conventionally believed to be populated by simple, developing societies. What we find there, however, is a collection of artifacts so masterfully crafted that they challenge the entire timeline of human technical progress. We are talking about the enigmatic stone vases, thousands of which have been recovered from sites like Saqqara and Hierakonpolis. These are not crude, hand-shaped pots. They are exquisite vessels carved from some of the most brittle and difficult materials on Earth, including schist, diorite, and rock crystal. Their beauty is undeniable, but it's their mind-boggling geometry and flawless finish that truly captivates engineers and archaeologists alike. Consider the physical form of these vases. Many feature wide, spherical bodies that taper into impossibly long, slender necks, culminating in delicate, flared lips. Some have internal shoulders, abrupt changes in diameter deep inside the vessel, while others exhibit a perfect, uniform thinness throughout their entire structure. To achieve this kind of hollowed-out, symmetrical form in a material as unforgiving as diorite is a monumental challenge, even for today's master craftsmen using diamond-tipped tools on a computer-controlled lathe. The paradox is staggering. These artifacts, some dated to over 5,000 years ago, display a level of precision that suggests the use of advanced fixed-axis machining. The symmetry is so perfect that when you roll one of these vases on a flat surface, it doesn't wobble in the slightest. It rotates as smoothly as a high-quality bearing. This isn't the result of hand carving. This is the signature of a tool that spun the workpiece at a high, consistent speed, allowing a cutting tip to uniformly remove material from all sides simultaneously. The mystery only deepens when we examine the surfaces. On many of these vases, there are no visible tool marks, no scratches, no gouges, no signs of the erratic chipping you would expect from hand-held stone tools. The interior surfaces, particularly within those long, thin necks, are as smooth and polished as the exterior. How do you polish the inside of a narrow, flask-like neck in a solid piece of stone without leaving any telltale marks? Using a piece of wood or stone with an abrasive paste would be incredibly difficult to control and would almost certainly leave concentric or linear scratches. The flawless, almost injection-molded quality of these interiors suggests a different process entirely, perhaps one involving a polishing technique that worked the material uniformly from all directions at once. So, how were they made? The mainstream explanation often points to the use of tubular copper drills and the laborious process of grinding with sand abrasives. While this method can, in theory, create holes, it completely fails to explain the complex external and internal contours. How do you create a flared lip or an internal shoulder using a simple straight drill? How do you achieve a perfectly spherical hollow inside a block of stone without any guiding mechanism? The absence of tool marks is perhaps the most damning evidence against simple manual methods. It implies a machining process where the cutting tool was not only fixed and stable, but also moved with such precision and speed that it effectively sheared the stone away, leaving a near-optical finish. Some researchers have proposed the use of a sophisticated, bow-driven lathe, but even that requires a level of precision engineering for the spindle and bearing assemblies that we don't attribute to pre-dynastic peoples. These vases are not primitive experiments, they are the refined products of a mature and sophisticated manufacturing tradition. They stand as a silent, elegant testament to a forgotten chapter of high technology, suggesting that the roots of precision engineering reach much deeper into our past than we have ever been willing to admit. Now, as we grapple with the immense logistical challenges of moving and lifting millions of multi-ton stone blocks, a truly revolutionary theory emerges, one that proposes a solution so elegant it could rewrite the very definition of ancient construction. This is our 9th piece of evidence, and it comes not from an archaeologist but from a materials scientist. The late Professor Joseph Davidovits introduced what is known as the geopolymer theory, a compelling hypothesis suggesting that the massive limestone blocks of the Great Pyramid were not all hauled from distant quarries, but were instead a form of sophisticated ancient concrete cast directly in place. Davidovits's background in chemistry led him to analyze the stone from a completely different perspective. He noticed peculiarities that didn't align with natural limestone. For instance, the blocks contained tiny, uniform air bubbles, something you would expect to find in a man-made, poured material as trapped air escapes, but not typically in sedimentary rock formed under immense pressure over millions of years. Even more telling is the presence of organic fibers and hair within the stone matrix. These are not fossils, they are foreign materials that somehow became embedded in the limestone. If these blocks were carved from a solid quarry bed, how did strands of hair and plant fibers get locked deep inside the stone? The most logical explanation is that they fell into a liquid or semi-liquid slurry as it was being mixed and poured, becoming permanent inclusions in the cast block. So, how would this geopolymer process have worked? The theory proposes that the Egyptians used a soft, natural limestone from the Giza plateau itself, which is rich in the mineral kaolinite. They would have crumbled this relatively soft stone into a powder. Then, by mixing this powder with water, lime, and a key activator, most likely a salt-based mineral like natron or even a caustic soda derived from plant ashes, they would create a chemical reaction. This reaction, a process known as geopolymerization, would transform this muddy slurry into a reconstituted limestone that is chemically identical to the natural stone, but with its microstructure rearranged. It would be like creating an artificial rock that is just as hard and durable as the real thing, but with the enormous advantage of being pourable. Think of it as the ancient world's version of modern concrete, but with a final product so perfect that for centuries everyone simply assumed it was quarried. This theory elegantly solves some of the most perplexing logistical puzzles of the pyramid's construction. The challenge of transporting and precisely placing over 2 million blocks, some weighing up to 70 tons, becomes vastly more manageable if the bulk of the material was mixed and cast on site. Instead of an army of laborers dragging impossibly heavy stones up massive ramps, you would have teams efficiently creating a kind of industrial-scale mud pie, pouring the geopolymer mixture into wooden molds layer by layer. This would also explain the astounding precision of the block fitting. When you pour a liquid material against a previously set block, it naturally takes on its exact shape, creating that famously seamless razor blade-proof joint without any need for microscopic level milling. The process would be faster, require far less brute force labor, and eliminate the need for the colossal ramps for which we have found no definitive archaeological evidence. It presents a vision of the Giza plateau not as a chaotic quarry site, but as a highly organized, almost factory-like production facility, where chemistry and engineering combine to create one of the wonders of the world. This narrative of lost high technology finds perhaps its most gleaming and undeniable proof not in stone, but in metal. Our 10th piece of evidence takes us into the realm of ancient Egyptian metallurgy, where the artifacts left behind reveal a technical prowess that rivals, and in some cases even surpasses, the capabilities of later civilizations. We often picture the ancient Egyptians as a Bronze and Copper Age culture, and while that's true for their common tools, their work with precious and exotic metals tells a completely different, far more advanced story. Consider the breathtaking artistry found in the jewelry of pharaohs like Tutankhamun. Among the spectacular death mask and the golden shrines, we find objects that are beautiful not just for their design, but for their microscopic perfection. One of the most telling examples is the existence of finely woven gold wire. This isn't simply hammered or twisted metal. This is wire of a consistent, hair-thin diameter woven into intricate chains and meshes. To produce such wire using only basic tools is virtually impossible. You cannot hammer gold to such a uniform thinness without it breaking. The creation of this kind of wire points directly to the use of a specific, sophisticated tool, the draw plate. A draw plate is a thick, hardened plate of metal, typically iron or steel, pierced with a series of holes of gradually decreasing diameter. To make wire, a craftsman would take a thicker gold rod, point its end and pull it through the largest hole. They would then pull it through the next smallest hole, and the next, each pass stretching and thinning the metal while simultaneously hardening it, until the desired, perfectly uniform thickness was achieved. This is a technology we don't officially attribute to the ancient world until centuries later. The presence of this fine wire is a silent but powerful testament to a workshop that contained not just jewelers' benches, but what amounted to an industrial tool set. It implies they had the means to create and harden these essential iron plates, and the engineering understanding of metallurgical properties like ductility and work hardening. They weren't just shaping metal, they were engineering it at a microscopic level. But if the worked gold points to sophisticated tool-making, another discovery points to something even more profound, an advanced understanding of material science and a celestial connection. In a pre-Iron Age burial at Giza, dating back to around 3200 BC, archaeologists uncovered a string of iron beads. This discovery is on its own anachronistic. The Iron Age in Egypt wouldn't begin for another 2,000 years. So how did these people have iron beads? The answer, when scientists analyzed them using modern methods like neutron activation and electron microscopy, was written in the stars. The beads contained a high percentage of nickel, around 7.5%, a composition that is the distinctive fingerprint of meteoritic iron. This is a staggering revelation. It means that thousands of years before we believe humans learned to smelt iron from terrestrial ore, the ancient Egyptians were already working with this ultra-rare heavenly metal. The process of taking a lump of meteorite and transforming it into a series of small, drilled beads is a technological marvel in itself. meteoritic iron is incredibly hard and brittle. To work it, they would have had to repeatedly heat and hammer it in a process called annealing, all while carefully controlling the temperature to avoid destroying the metal. They recognized this strange, heavy stone from the sky as a unique and precious material, and they developed the specialized, complex metallurgical techniques needed to shape it. This wasn't a lucky accident, it was a deliberate scientific process. They understood that this celestial metal was different from the copper and gold they knew, and they valued it so highly they included it in a sacred burial context. These beads are more than just jewelry. They are humanity's first known foray into ironworking, a science born not from earthly minds, but from a deep curiosity about the cosmos and a relentless drive to master the materials it provided. Together, the woven gold and the cosmic iron tell a unified story of a civilization that was not primitive in its technology, but was instead a sophisticated pioneer, manipulating the very building blocks of matter with a skill that would not become common for millennia. Now we turn our attention from the pyramids to the silent, enigmatic sentinel that guards the Giza plateau, the Great Sphinx. This colossal limestone statue, with the body of a lion and the head of a pharaoh, has long been attributed to the Old Kingdom pharaoh Khafre around 2500 BC. But what if this attribution, a cornerstone of conventional Egyptology, is fundamentally incorrect? Our 11th piece of evidence is not an artifact you can hold, but a pattern etched into the very stone of the Sphinx itself by the relentless forces of nature. This is the water erosion hypothesis, a geological argument that challenges the statue's accepted age and points to a timeline so ancient it rewrites human history. The evidence lies in the unmistakable weathering patterns on the Sphinx's body and the deep trenches of its enclosure. Geologists like Dr. Robert Skock of Boston University have meticulously studied these features, and what they found contradicts the standard narrative. The erosion on the Sphinx is not uniform. While the head shows weathering consistent with wind and sand, the core body and the enclosure walls display deep, undulating, and vertical fissures. These are not sharp, angular cracks from tectonic shifts or the random pitting from wind-blown sand. Instead, they present a classic textbook example of precipitation-induced weathering. This is the kind of deep, rounded, and vertical channeling that occurs when heavy, sustained rainfall pours over a limestone surface, dissolving the softer minerals and carving runoff patterns as the water cascades downward. You can see identical patterns on much older limestone outcrops in regions that experience heavy rain, but you do not see them on other structures in Giza that are definitively from the Old Kingdom period. Here is where the mystery deepens exponentially. Egypt's climate for the last 5,000 years has been overwhelmingly hyper-arid, a dry, desert environment where rainfall is minimal and sporadic. The kind of torrential, prolonged downpours needed to carve these deep, vertical channels on the Sphinx simply have not occurred in this region for millennia. So, when was the last time the Giza Plateau experienced a climate wet enough to produce this specific type of erosion? Paleoclimatological data points to a period known as the Neolithic subpluvial, a time of significant rainfall that ended around the middle of the 4th millennium BC. But for erosion of this magnitude to occur, the Sphinx would have had to be standing exposed, subject to these rains, for many centuries. This pushes the initial carving of the Sphinx's core body back to a period far earlier than the reign of Khafre, potentially to a time around 7,000 to 9,000 years ago or even earlier. This proposed timeline is revolutionary. It suggests that the core structure of the Sphinx is not a 4,500-year-old monument, but a 12,000-year-old relic, a survivor from a vastly remote epoch. Mainstream Egyptology counters that the weathering could have been caused by other processes, such as wind erosion, capillary action from groundwater, or even the effects of halite salt crystallization. However, these explanations struggle to account for the pronounced vertical profile of the erosion. wind and sand typically create horizontal, scoured features, not deep, vertical grooves that follow the path of least resistance for flowing water. The salt crystallization theory also falls short, as it tends to cause surface flaking and disintegration rather than the large-scale, channel-like features visible on the enclosure walls. The water erosion pattern remains the most coherent geological fit. If the Sphinx is indeed this ancient, the implications are staggering. It would mean that a sophisticated, organized society capable of planning and executing a project of this colossal scale existed thousands of years before the rise of the first pharaohs. This was a time conventionally believed to be populated by small, nomadic bands of hunter-gatherers, not a civilization with the architectural and engineering prowess to carve a 240-foot-long monument from the living bedrock. This pre-pharaonic civilization, whoever they were, would have possessed not only the technical skill but also a profound understanding of astronomy, as the Sphinx is precisely oriented toward the rising sun on the equinoxes, and geology, having selected a prime limestone deposit for their work. The Sphinx, therefore, becomes more than a mysterious statue. It transforms into a potential time capsule from a lost age, a piece of evidence that our historical timeline is missing a foundational chapter, a chapter written not in hieroglyphs but in the very rain-scarred stone of the Giza plateau. This obsession with mathematical precision didn't end with individual artifacts or the pyramids themselves. It seems to have been a foundational principle woven into the very fabric of their most sacred spaces. Our 12th piece of evidence takes us from the desert plateau of Giza to the bustling heart of ancient Thebes, to the sprawling temple complexes of Karnak and Luxor. Here, we don't find advanced machinery or baffling artifacts, but something potentially more profound: complex geometry and sophisticated mathematical ratios encoded directly into the temple layouts and architectural proportions. This isn't merely decorative or artistic flair. It represents a deep, systematic understanding of mathematics and its harmonic relationship with the physical world, a knowledge base that appears in the archaeological record with a sudden and inexplicable maturity. When you walk through the great hypostyle hall at Karnak with its forest of 134 colossal columns, the overwhelming sensation is one of sheer scale. But if you were to take a step back and view the temple from an architectural plan, a hidden order begins to emerge. The entire complex, from the positioning of its obelisks to the alignment of its pylons and courtyards, appears to have been designed using what we now call the golden ratio, often represented by the Greek letter phi, approximately 1.618. This ratio is found throughout nature, from the spiral of a nautilus shell to the arrangement of seeds in a sunflower, and it's renowned for its aesthetically pleasing properties. The ancient Egyptians seem to have recognized this universal harmony and deliberately embedded it into their most important structures. The width of a courtyard might relate to its length by this ratio, or the height of a pylon gate might be precisely phi times the width of its entrance. This consistent application across different building phases and centuries suggests this wasn't a happy accident, but a strictly adhered to canon of sacred architecture. Beyond the golden ratio, we find the fingerprints of another famous mathematical sequence, the Fibonacci sequence, where each number is the sum of the two preceding ones: 0, 1, 1, 2, 3, 5, 8, and so on. As this sequence progresses, the ratio between successive numbers gets closer and closer to the golden ratio. Analysis of floor plans and elevation profiles at Luxor Temple reveals dimensions that correspond remarkably well to these Fibonacci numbers. For instance, the proportional relationship between the successive sections of the temple, the courtyard, the colonnade, the hypostyle hall, often mirrors these ratios. The implication is staggering. This mathematical concept wouldn't be formally identified in the West for another 2,000 years by Leonardo of Pisa, known as Fibonacci. Yet here it is, meticulously laid out in stone along the banks of the Nile in the 2nd millennium BC. This points to a priestly and architectural class that didn't just use simple arithmetic for counting and measuring. They were working with advanced, abstract numerical theories. Why would they go to such extraordinary lengths? The answer likely lies in the intersection of science, religion, and their understanding of cosmic order, which they called math. For the Egyptians, the temple was not just a building for worship. It was a microcosm of the universe, a sacred machine designed to harmonize the earthly realm with the divine. By building these perfect mathematical relationships into the structure, they were literally encoding the laws of creation into its walls. They believed that by aligning their architecture with these universal constants, they could tap into the fundamental power that sustained existence. This transforms these temples from simple places of ritual into active cosmological instruments. The precision required to execute these designs on such a massive scale is yet another clue to their advanced capabilities. Laying out a small building with geometric precision is one thing, but to maintain these perfect proportions across a complex like Karnak, which was built, expanded, and modified by numerous pharaohs over 2,000 years, requires a master plan and a system of knowledge that was accurately passed down through generations of architects and priests. This phenomenon of encoded knowledge presents a significant historical puzzle. In the conventional timeline, we expect to see a gradual evolution of mathematical understanding from simple counting to basic arithmetic to more complex geometry. But in ancient Egypt, this knowledge seems to appear almost fully formed. There are no surviving texts that explicitly outline the theory behind the golden ratio or the Fibonacci sequence. The Rhind mathematical papyrus, one of our key sources for Egyptian math, shows practical arithmetic and geometry for calculating areas and volumes, but nothing that directly explains the sophisticated proportional systems we see in their architecture. This suggests that the highest levels of their mathematical knowledge were considered sacred, perhaps an esoteric tradition passed down orally within closed priestly schools or guilds of master builders. The temples themselves, therefore, become their true textbooks. The stones are the pages and the proportions are the language. To understand their full scientific achievement, we cannot rely on papyri alone. We must measure the monuments. This disconnect between the practical texts we have found and the breathtaking abstract genius displayed in the buildings strongly implies that a vast body of their advanced knowledge has been lost, leaving behind only these silent, geometric echoes in the ruins of their greatest temples. Now, let's turn our attention to a challenge of a different kind of scale. Not the microscopic precision of a vase or the mathematical encoding of a temple, but the sheer, overwhelming physics of moving mountains of stone across the desert. Our 13th piece of evidence confronts the colossal logistical puzzle of transportation. Scattered across Egypt are the remnants of this epic endeavor, the twin colossi of Memnon, each a seated statue of Pharaoh Amenhotep III weighing an almost incomprehensible 1,000 tons, and the scores of granite obelisks, some like the Lateran obelisk, which originally weighed over 450 tons, that were quarried in Aswan and erected hundreds of miles to the north. The question is not just how they carved these behemoths, but how on earth they moved them. The official theory, the one you'll find in textbooks, paints a picture of immense, coordinated human effort. It's a story of sledges, ropes, and rollers. The concept is that a giant stone statue or obelisk would be levered onto a massive wooden sledge. This sledge would then be placed on a track of wooden rollers. Teams of hundreds or even thousands of laborers would then pull on ropes, dragging the sledge forward. To reduce friction, the theory suggests they might have poured water or a slurry of mud in front of the sledge, creating a slick surface. For river transport, the stones would be loaded onto specially built gigantic barges during the Nile's annual flood, when water levels were highest, and then floated to their destination. It's a logical, step-by-step process that seems to make sense on paper. But when you begin to apply real-world physics and logistics to this theory, it starts to strain under the weight of its own improbability. Let's take the Colossi of Memnon. Each statue is estimated to weigh around 720 tons. Imagine trying to pull the equivalent of 2 fully loaded jumbo jets across miles of sand and rock using only ropes and wooden rollers. The first and most obvious problem is the rollers themselves. Under such an immense concentrated load, wooden rollers, even those made from the hardest available timber, would have a tendency to splinter, crack, or simply be crushed into the soft ground. You wouldn't be rolling so much as you'd be constantly replacing pulverized wood and digging your cargo out of the dirt. The friction, even on a lubricated surface, would be astronomical. Experiments and engineering calculations suggest that moving a 700-ton load on a sledge, even on the best-prepared track, could require a pulling force equivalent to the effort of well over 1,000 men. Coordinating that many people to pull in perfect unison without the ropes tangling or the load shifting is a managerial and physical nightmare of almost unimaginable proportions. Then there's the issue of the barges. To transport a 450-ton obelisk by water, you would need a barge of immense size and strength. The buoyancy and stability required are enormous. A sudden shift in weight from a wave or an unbalanced load could capsize the entire vessel, sending its priceless cargo to the bottom of the Nile. How did they build such strong, wide, and stable wooden ships without the advanced carpentry and engineering principles we associate with much later seafaring? And how did they actually load these multi-hundred-ton stones onto the barge without a massive, stationary dock crane? The process of transferring that much dead weight from land to a floating vessel without catastrophic failure is a puzzle in itself that the official theory often glosses over with a simple wave at levers and ramps. This gap between the proposed method and the staggering practical challenges is precisely what leaves the door open for more speculative and perhaps more plausible advanced methods. One fascinating theory involves a fundamental change to the medium the stone was moving on. What if the ancient engineers didn't just pour water in front of the sledge, but instead created a more sophisticated system? Some researchers have proposed the use of a temporary paved trackway, not of stone, but of a slick, compacted clay that could be repeatedly wetted to form an extremely low friction surface. This would be far more effective than simply wetting sand. Another, more ingenious idea suggests they might have used a mechanical advantage system far beyond simple ropes. While the wheel wasn't used for load bearing in this way, the principle of the pulley was known. Could they have employed complex arrangements of pulleys to dramatically multiply their pulling force, reducing the number of men needed and allowing for more controlled, precise movement? The evidence for such systems hasn't survived, but their absence from the archaeological record doesn't mean they didn't exist. Wood and rope perish over millennia. Perhaps the most captivating theory of all involves a different approach to the problem of friction entirely. What if the ancient Egyptians had discovered a way to make the stone itself easier to move? This might sound like science fiction, but consider the practical knowledge they clearly possessed. Is it possible they had developed a technique to temporarily alter the properties of the surface over which the sledge moved? Some have even wondered, based on tomb paintings that show a person standing on the front of a sledge seemingly pouring a liquid, if the substance wasn't just water, but a special lubricant mixture that dramatically reduced the coefficient of friction. While we have no direct proof of such a chemical technology, its potential existence would elegantly solve the core problem of moving these impossible weights. The transportation of the Colossi of Memnon and the Great Obelisk stands as one of the most visible yet unexplained achievements of the ancient world. It's a testament not just to brute force and vast labor pools, but to a potential lost science of logistics, a profound understanding of physics, materials, and large-scale project management that allowed them to perform feats that would be considered ambitious even with modern machinery. Returning to the site of the Osirian at Abydos, we encounter a 14th clue, one that is literally foundational. While the structure's colossal architecture is staggering, it is the floor beneath our feet that presents a quiet yet equally powerful piece of the puzzle. The entire floor of the main hall is paved with enormous slabs of basalt, a dense, incredibly hard volcanic rock formed from rapidly cooled lava. To cut and shape even a single block of this material with simple tools would be a formidable task, but the true marvel here lies not in the individual slabs but in their collective assembly. These massive stones are fitted together with such exacting precision that the entire floor surface is perfectly, almost unnervingly, flat across its vast expanse. To understand the significance of this, consider the challenge of creating a perfectly level surface over a large area today, even with our advanced technology. A modern mason or construction crew uses laser levels, long straight edges, and precision grinding equipment to ensure a floor is flat, eliminating any high spots or dips that would be noticeable over distance. The builders of the Osirian achieved this same result on a monumental scale, working with one of the most difficult materials imaginable. Basalt is significantly harder than granite. It's a stone that rapidly dulls modern steel tools. The traditional toolkit of copper chisels and dolerite pounding stones would have been laughably inadequate for milling these slabs down to a uniform plane. The process required to achieve this flatness suggests something far more advanced than brute force. It implies the use of a sophisticated leveling technique and a polishing method capable of working the entire floor as a single, continuous surface. The implications of this are profound for understanding their capabilities. This isn't merely about making a floor look nice, it's a feat of advanced engineering geometry. Achieving this level of flatness requires the ability to accurately measure minute variations in height across a wide area, and then systematically remove material until a perfect plane is established. This points to the use of master straight edges, perhaps made of hard stone, that were themselves precision ground, and a systematic understanding of surface plate calibration. Furthermore, the polishing of the basalt to its final smooth finish adds another layer of complexity. This kind of lustrous, uniform polish on such a hard stone is typically achieved today with industrial machinery using progressively finer abrasives under consistent pressure. The Osirian floor stands as a testament to a lost methodology, a process where the builders treated a massive, multi-slab floor not as separate pieces, but as a single workpiece to be machined to perfection. It is a permanent, level datum point etched in stone, suggesting its creators possessed a geometric and engineering sensibility that we would easily recognize as modern, yet it lies buried in the sands of a civilization we are only just beginning to comprehend. But the architectural and logistical marvels of the Giza plateau only tell half the story. To truly grasp the genius of its builders, we must lift our gaze from the desert sands to the night sky itself, where our 15th piece of evidence is written in the constellations. The entire Giza complex is not merely a collection of tombs, it is a stunningly accurate terrestrial map of the heavens, specifically of the Orion constellation, demonstrating a long-term, sophisticated astronomical understanding that guided its construction on a truly cosmic scale. The most famous celestial correlation is the precise arrangement of the three main pyramids. They are not placed in a straight line or a random cluster. Instead, their layout across the plateau mirrors the three stars that form Orion's belt, Al-Nitak, Al-Nilam, and Mintoka. When you superimpose an image of the belt stars onto an aerial photograph of the pyramids, the correlation is breathtaking. The two larger pyramids, Khufu and Khafre, align diagonally, just as the two brighter stars do, while the slightly offset and smaller pyramid of Menkaure perfectly mirrors the third, fainter star. This is not a rough approximation. The relative sizes of the pyramids and their positional relationships on the ground correspond with the relative brightness and spatial arrangement of the stars above. This Orion correlation theory suggests the ancient surveyors were not just building for the glory of a pharaoh, but were deliberately creating a permanent scale model of a sacred part of their cosmos on Earth. This celestial connection becomes even more profound when we shift our focus from the external arrangement to the internal architecture of the Great Pyramid itself. Deep within its core, two narrow shafts, each only about 8 inches square, angle upwards from the king's and queen's chambers. For a long time, their purpose was a complete mystery, often dismissed as mere ventilation shafts. However, advanced astronomical software has allowed researchers to run the sky back in time, and the discovery was revolutionary. Around 2500 BC, the era of the pyramid's construction, the southern shaft from the king's chamber was aimed directly at the heart of the Orion constellation, targeting the very star Al-Nitak that the pyramid itself represents on the ground. Simultaneously, the southern shaft from the Queen's chamber was precisely targeted to frame the star Sirius, the brightest star in the night sky, which the ancient Egyptians associated with the powerful goddess Isis. The implications of this are staggering. It means the pyramid's interior was designed as a kind of precision astronomical instrument, its shafts functioning as fixed sightlines to funnel the spiritual essence, or ka, of these specific celestial deities directly into the chambers. This was a sacred technology, blending profound spiritual belief with exacting scientific observation. The engineering required to incorporate these long, narrow, and perfectly angled shafts into the pyramid's multi-million block structure during its construction is a feat of foresight and geometric calculation that is difficult to overstate. They had to account for the precise latitude of Giza, the atmospheric refraction, and the subtle movements of the stars over centuries to ensure these shafts would be aligned at the exact moment the pyramid was sealed. This was an astronomy of immense patience and long-term planning, a science that viewed time in millennia, not years. This grand celestial blueprint forces us to reconsider the very purpose of Giza. It was far more than a necropolis. It was an active portal, a machine designed to harmonize the earthly realm with the divine cosmos. The mirroring of Orion's belt on the ground created a powerful symbolic link between the kingdom of the pharaohs and the realm of the god Osiris, with whom the Orion constellation was intimately connected. By building this cosmic duplicate, they were anchoring celestial power to a specific location on Earth, ensuring the eternal cycle of death and rebirth for the king and the stability of the entire kingdom. The Giza complex, therefore, stands as the ultimate expression of a civilization that saw no separation between science and spirit, between the meticulous measurement of the stars and the sacred journey of the soul. It is a permanent testament to a people who not only mapped the earth but who also mastered the sky, encoding their cosmic knowledge into the very stones of their greatest monuments. Moving from the celestial alignments of Giza and the monumental logistics of construction, we arrive at a domain of ancient expertise that touches the very fabric of human life and survival. Our 16th piece of evidence shifts the focus from stone and sky to flesh and bone, examining the advanced medical knowledge and surgical tools of ancient Egypt. This isn't a realm of superstition or mere guesswork. The artifacts and texts that have survived reveal a culture that approached medicine with a startlingly rational, scientific, and highly skilled methodology, suggesting a level of medical technology that seems to appear fully formed in the historical record. Let's begin with the tools themselves. When we picture an ancient Egyptian surgical kit, we might expect crude, ineffective instruments. The reality, preserved in tomb findings and museum collections, is quite the opposite. Archaeologists have uncovered sets of bronze and copper tools that are immediately recognizable to any modern surgeon. These include finely crafted scalpels with razor-sharp edges, bone saws with intricate teeth, forceps of various sizes for grasping and extracting, and even specialized probes and spatulas. The sophistication is in the design. These weren't generalized cutting tools, they were purpose-built for specific procedures. The forceps, for example, were engineered with a precise grip to remove foreign objects from wounds or to clamp blood vessels, demonstrating an understanding of both anatomy and the mechanics of surgery. The presence of these refined instruments points to a professional class of surgeons who practiced their craft with a standardized set of high-quality equipment, a concept we associate with much later periods in history. This empirical approach is crystallized in one of humanity's oldest surviving medical documents, the Edwin Smith Papyrus, dating to around 1600 BC, but believed to be a copy of a much older text from 3000 BC. This papyrus is a revolutionary window into the ancient mind. Unlike other medical texts that blend physical treatment with magical incantations, the Edwin Smith Papyrus is relentlessly rational and scientific. It reads like a modern trauma surgeon's field guide. The document systematically describes 48 cases of injuries, starting at the head and moving down the body. For each case, it provides a logical structure: the examination, the diagnosis, the treatment, and the prognosis. The physician is instructed to declare one of three verdicts for a patient: an ailment I will treat, an ailment I will contend with, or an ailment not to be treated, showing a pragmatic understanding of medical limits. The anatomical knowledge displayed is profoundly advanced. The papyrus accurately describes the meninges, the membranes that envelop the brain, and it details the cerebrospinal fluid. It correctly identifies the physiological effects of a broken neck, noting the resulting loss of sensation and control in the limbs. It even documents the pulse of the heart and its connection to the entire circulatory system, a concept that wouldn't be formally established in the West for another 2 millennia. This isn't vague speculation. It's the result of direct observation, likely gained from extensive experience with wounds and quite possibly from systematic dissection. The text's clinical detachment and systematic methodology reveal a medical tradition grounded in observation, evidence, and a sophisticated understanding of the human body's structure and function. Perhaps no single procedure better illustrates the audacious skill of these ancient surgeons than trepanation, the practice of drilling or cutting a hole into the human skull. This was not a rare or experimental operation. Evidence of trepanation has been found on numerous Egyptian skulls, and many of them show clear signs of healing, meaning the patients survived the incredibly invasive surgery. The technique required an almost unbelievable level of precision and anatomical knowledge. The surgeon had to carefully scrape or cut through the scalp, then navigate through the skull bone itself, all while avoiding the delicate dura mater, the protective layer surrounding the brain. A single slip could mean fatal damage or severe infection. The tools used for this were likely specialized bronze drills with bow-driven mechanisms to achieve a consistent rotation along with sharp scrapers. The survival rate for these operations indicates that the surgeons not only possessed a steady hand but also a comprehensive understanding of post-operative care, including the management of pain, the prevention of infection with honey or resin-based antiseptics, and the cleaning and dressing of the wound. Performing successful brain surgery in an era assumed to be medically primitive stands as a powerful testament to a developed and highly specialized medical technology. This combination of refined tools, systematic documentation, and successful complex surgical intervention paints a portrait of an ancient civilization that had mastered the science of healing to a degree that would not be seen again for centuries, forcing us to completely reevaluate our assumptions about their technological and scientific landscape. This profound mystery of ancient illumination leads us from the bright halls of temples down into the deepest, most elaborate tombs in the Valley of the Kings, presenting our 17th piece of evidence. If the Dendera reliefs suggest a potential for advanced lighting, the tomb of Pharaoh Seti I, known as KV-17, makes the case for its absolute necessity. This is not a simple burial chamber. It's a sprawling, subterranean masterpiece, a labyrinth of corridors and halls that descends over 300 feet into the heart of the mountain, every single inch of its walls and ceilings covered in the most exquisite, finely carved and vibrantly painted hieroglyphs. To stand in its deepest chamber is to be surrounded by a gallery of artistic perfection, executed in a place of perpetual, absolute blackness. And here we encounter the central, unsettling puzzle, the astonishing absence of soot. The conventional explanation of torch and oil lamp light collapses under the weight of simple physics and chemistry. Open flames produce smoke and soot. It is an inescapable byproduct of combustion. If teams of artists had worked for years in these confined, poorly ventilated spaces using torches or simple lamps, the evidence would be indelibly stamped onto the ceiling. We would see a thick, black, carbonized layer coating the exquisite artwork, especially in the recessed ceilings where smoke naturally accumulates. Yet, when you look up in KV-17 and many other royal tombs, the white limestone ceilings above the vibrant paintings are often pristine, showing no trace of this inevitable residue. This isn't just an isolated observation, it's a consistent feature across numerous deep-cut tombs. Furthermore, consider the practical working conditions. An oil lamp provides a weak, flickering, and localized light. To carve a relief with the precision of a master engraver, you need steady, bright, and shadow-free illumination across the entire wall you are working on. A handful of smoky lamps casting dancing shadows would make such precise work impossible. The artists would have been struggling to see, their eyes straining in the gloom, and the quality of the work would undoubtedly have suffered. Yet the artwork is flawless. This paradox forces us to confront a very real possibility. The ancient artisans possessed a light source that was clean, bright, and steady. So, what alternatives could have provided such pristine illumination? One of the most discussed theories involves an ingenious application of reflected sunlight. The concept is that the Egyptians could have used a series of highly polished copper or bronze mirrors, strategically positioned to bounce sunlight from the outside, down the long, descending corridors and into the deepest chambers. We know for a fact that they manufactured mirrors with highly reflective surfaces, and the principle of light reflection was well within their understanding. In theory, a perfectly aligned chain of mirrors could have funneled daylight into the abyss. However, when you model this system in practice, significant problems emerge. Each reflection off a metal mirror, even a highly polished one, results in a substantial loss of light intensity. By the time the light traveled around multiple corners and down several hundred feet, the beam would be incredibly dim and diffused. More critically, the sun moves across the sky. To maintain a constant light source deep underground, the mirrors would need constant, minute adjustments throughout the day, a logistical nightmare requiring teams of attendants dedicated solely to mirror alignment. While this method might have provided some supplemental light for initial rough work, it seems inadequate to illuminate a vast chamber brightly and evenly enough for the years of detailed painting and carving that KV-17 required. This inadequacy of simple mirror systems fuels the speculation for something more exotic and perhaps more permanent. Could the answer lie not in bringing light down, but in creating it within the tomb itself? This brings us back to the provocative possibility of an ancient electrical technology hinted at by finds like the Baghdad battery. If such cells existed, even in a limited capacity, could they have been connected to a form of arc lighting or to a different type of illumination we haven't yet considered? The concept of a wireless, flameless light might sound like fantasy, but it would perfectly explain the lack of soot and the even, shadow-free quality of light needed for such precise artwork. Another fascinating, though highly speculative, idea involves the use of bioluminescence. Certain natural materials, like specific fungi or marine organisms, can produce a cool, chemical light. Is it possible the Egyptians discovered and cultivated a biological light source, perhaps contained in large, transparent vessels that acted as living lamps? While there's no direct archaeological evidence for this, it remains a tantalizing thought experiment that highlights the depth of the mystery. The true answer may be a combination of methods or something we have not yet conceived. The undeniable fact remains that the artists of KV-17 and similar tombs worked in conditions that we, with our historical assumptions, would find impossible. They executed their masterpieces not in a flickering, smoky haze, but in what appears to have been a clear and brilliant light. This isn't a minor detail of archaeology. It's a fundamental question about the tools and technologies available to these ancient craftsmen. The pristine walls of Seti's tomb are more than just a beautiful artifact. They are a silent, powerful argument for a lost method of illumination, a technology that allowed humanity to conquer the deepest darkness thousands of years before the electric light bulb was ever dreamed of. Yet the echoes of this lost technology are not confined to the banks of the Nile. To fully appreciate the scope of this ancient mystery, our 18th piece of evidence compels us to take a comparative journey across the Atlantic to the high-altitude plains of Bolivia. Here, at the site of Puma Punku, part of the larger Tiwanaku complex, we find architectural anomalies so startling that they challenge the very foundations of our linear view of human history. The ruins of Puma Punku present a spectacle of shattered megalithic grandeur, but it is the intricate detail of the individual stone pieces, rather than their collective scale, that truly stuns the observer. We are confronted with a collection of andesite and red sandstone blocks, many of which exhibit a level of geometric complexity and surface finish that looks unmistakably machined. Among the most famous artifacts are the so-called H-blocks. These are not simple, rectangular stones. They are precise, modular components, each featuring a series of identical, recessed ports and protruding tabs that interlock with an almost Lego-like logic. The consistency across these blocks is breathtaking. Each cutout, each flange is a perfect mirror of the others, as if they were all produced from the same master template or die. The edges are razor sharp, the corners are perfect 90 degrees, and the surfaces are flawlessly flat. When you place a modern engineer's square against these stones, it meets the surface without any gap, a level of precision that would be impressive even with today's computer-guided milling machines. This isn't the result of pounding stones against other stones. This is the signature of a technology that could make repeated, identical cuts into incredibly hard stone with unerring accuracy, suggesting the use of advanced saws and precision-guided tools. The mystery only deepens when we examine the methods used to create these forms. Some of the andesite blocks feature deep, narrow channels and drill holes that are perfectly cylindrical. The interior surfaces of these channels are as smooth as glass, showing no signs of the striations or variations you would expect from a handheld, abrasive core drill. Instead, they suggest the use of a tool that rotated at a very high speed with immense stability, effectively liquefying the stone as it passed through, leaving behind a polished, almost vitrified finish. Furthermore, many slabs show evidence of complex, three-dimensional cut angles that change direction within the same stone, creating intricate shapes that would be extraordinarily difficult to fabricate without multi-axis machining capability. The builders of Puma Punku weren't just stacking rocks. They were engineering with stone as a modern architect would engineer with pre-fabricated steel beams, creating a system of interlocking components designed for incredible structural integrity and assembly efficiency. While this site is geographically and culturally distant from ancient Egypt, the technological parallels are impossible to ignore. At both Puma Punku and at sites like the Valley Temple of Kaffa or the Serapeum, we see the same hallmarks of a lost high technology, the ability to cut and shape immense blocks of hard stone with machine-like precision, to create perfect right angles and flawless surface planes, and to execute complex geometric designs that defy simple hand tool explanations. This is not to suggest a direct cultural connection, but rather to point towards a haunting possibility that these similar technological fingerprints in disparate parts of the world may be independent manifestations of a shared and now lost chapter in human development. The perfection of the H-blocks and the milled surfaces of Pumapunku stand as a powerful, silent testament to a forgotten age of ingenuity, forcing us to consider that the story of human progress is not a simple, upward-sloping line, but perhaps a cycle with peaks of achievement that have since been obscured by the sands of time. But this entire narrative of lost high technology inevitably circles back to a fundamental and glaring contradiction. Our 19th piece of evidence forces us to confront the official toolkit of ancient Egypt, the very items displayed in museum cases around the world: copper chisels, stone dolerite hammers, and wooden wedges. According to conventional history, these were the primary instruments used to build the pyramids, carve the granite boxes of the Serapeum, and shape the diorite vases. Yet, when we place these simple tools against the immaculate, machined perfection of the artifacts they supposedly created, a profound disconnect emerges, one that becomes undeniable when we move from theory to practical experiment. Imagine taking a modern, sharpened copper chisel and attempting to cut a block of Aswan granite, one of the hardest stones on the planet. What would happen? The result is not a matter of speculation. It has been tested repeatedly by engineers and experimental archaeologists. The moment the soft copper edge meets the unyielding crystalline structure of the granite, it doesn't bite or slice, it mushrooms and deforms. After just a few strikes, the cutting edge is rounded over, blunted into uselessness. The copper, being significantly softer than the quartz and feldspar crystals in the granite, simply cannot maintain a sharp edge. You would spend more time repeatedly resharpening and rehammering your chisel than you would making any measurable progress on the stone. The process is not just slow, it is fundamentally ineffective. You might eventually pulverize the surface of the granite into a powdery dust through relentless pounding, but you could never achieve a clean, precise cut, a smooth, flat plane, or most tellingly, those razor-sharp internal 90-degree corners. The idea of using a soft copper chisel to hollow out the interior of a 100-ton granite box with complex undercuts is as practical as trying to carve a detailed ice sculpture with a warm spoon. The alternative tool often cited is the dolerite ball, a fist-sized stone harder than granite. The theory suggests that workers would pound these balls directly against the granite surface, slowly crushing the stone grain by grain. While this method can, over an immense amount of time, remove material, it is the antithesis of precision. The result of pounding with a round stone is a pitted, uneven, and concave surface, not the flawless, planar faces we see on the Serapeum sarcophagi. It is a technique of brutal force, incapable of producing the straight lines, perfect right angles, and mirror-like polish that define these ancient artifacts. The evidence left by such pounding would be a field of crushed stone and shattered dolerite balls, yet we do not find vast industrial-scale deposits of these materials at the sites where this precise work was done. The tools we have found in abundance are adequate for the rough quarrying of softer stones like limestone, but they are entirely insufficient to explain the fine, precision work on hard stones like granite, diorite, and basalt. This creates an inescapable logical impasse. We have the finished products which display clear evidence of advanced machining, fixed axis cutting, and polishing techniques. And we have a set of simple tools that are demonstrably incapable of producing that work. The only conclusion that bridges this gap is that the tools we see in museums represent the common, everyday tools of the civilization, perhaps used for softer materials and basic construction. But for the masterworks, for the projects that define their highest achievements, the ancient craftsmen must have possessed a separate, superior set of tools that were either so valuable they were meticulously conserved and recycled, or whose nature was so specific that they have not survived in the archaeological record. We are not necessarily talking about power tools, but perhaps about advanced alloy chisels, diamond-tipped saws, or complex compound bows driving drill bits at high speeds. The pristine granite boxes and the diorite vases are in effect the negative space left behind by these lost instruments. They are the permanent, silent witnesses to a technology that has vanished, leaving behind its magnificent creations but taking the secrets of its own making with it. This mastery over stone and logistics, however, would have been meaningless without a parallel command over another, far more fluid and vital element: water. Our 20th piece of evidence dives into the sophisticated hydraulic engineering that formed the lifeblood of ancient Egypt, revealing a civilization that didn't just rely on the Nile's annual flood, but actively managed and manipulated water on a monumental scale. This expertise demonstrates a profound understanding of hydraulics and civil engineering that was absolutely crucial for sustaining their society, and which may have been a hidden component in their most ambitious construction projects. Perhaps the most stunning testament to this early engineering audacity is the Sad el-Kafara, or the Dam of the Infidels, located in the Wadi Garowe near Cairo. Dating back to the Old Kingdom around 2600 BC, this structure is one of the oldest known dams in the entire world. Its scale was immense for its time. The dam was constructed as a massive gravity dam, meaning it relied on its own sheer weight to hold back the force of water. It spanned over 110 meters across the valley and stood roughly 12 meters high, with a core made of rubble and earth encased in meticulously laid stone walls. The vision behind it was staggering: an attempt to control the destructive flash floods that would roar through the wadi after rare desert storms, creating a reservoir to store water for quarry workers and perhaps even for local agriculture. The very concept of damming a desert valley shows a forward-thinking mindset that sought not just to adapt to the environment, but to fundamentally reshape it for human benefit. The sophistication of its design, however, is revealed in its ultimate failure. The dam was never completed, likely because it was overtopped and destroyed by a flood during its construction. Yet, this failure is itself a critical piece of evidence. Modern hydraulic analysis shows that the builders made a crucial, sophisticated calculation. They included a massive, stone-lined spillway on one side of the dam, designed to safely channel excess water around the structure during particularly heavy inflows. This proves they understood the principle that a dam couldn't simply block all water. It had to have a controlled release mechanism to prevent catastrophic failure. The fact that they anticipated this need for a spillway demonstrates a remarkably advanced grasp of hydrology and the dynamic forces of water. They weren't just piling up rocks, they were thinking like modern civil engineers attempting to manage hydraulic energy. The Sad el-Kafara stands as a poignant, half-finished monument to a bold experiment in water control, a clear indication that the drive to engineer the landscape was present at the very dawn of their monumental building period. Beyond these grand, singular structures, the true genius of Egyptian hydraulics was woven into the very fabric of the land through an extensive and ever-evolving network of canals and irrigation basins. This was not a haphazard system of ditches. It was a highly organized, state-managed grid designed to maximize the agricultural potential of the Nile's annual inundation. Using nothing more than simple tools and vast pools of organized labor, they transformed the Nile Valley into a vast, productive engine. They constructed feeder canals to direct floodwaters into vast, walled basins. Once the water, rich with fertile silt, had settled and deposited its nutrients, the excess was strategically drained away, leaving behind perfectly saturated fields ready for planting. This basin irrigation system required an incredible depth of topographic understanding and precise leveling over enormous areas to ensure water flowed where it was needed and drained efficiently. This was large-scale environmental engineering, a testament to their ability to plan, coordinate, and execute projects that sustained their population for millennia. Now, let's connect this mastery of water directly to the mystery of the pyramids. We've already explored the immense challenge of moving multi-ton stones. Could their hydraulic expertise have provided a solution? One compelling theory suggests that the Egyptians didn't just move stones over land, they moved them on water in a much more direct way than previously considered. The discovery of an ancient, large harbor at the foot of the Giza plateau supports the idea that materials were brought right to the construction site by boat. But the theory goes further, proposing that the builders created a series of canals and hydraulic lifts that brought the stones astonishingly close to their final positions. Imagine a system where the annual Nile flood was not just an agricultural event but a construction tool. As the floodwaters rose, they could have been channeled through temporary canals directly to the base of the plateau. Massive barges carrying stone blocks could have floated on this artificially elevated water, moving the stones much farther inland than would be possible today. The most radical part of this hydraulic hypothesis involves the final ascent. How do you lift a 70-ton block to the 100th course of the Great Pyramid? The traditional ramp theory has always been plagued by the lack of archaeological evidence for the massive ramps that would be required. An alternative proposed by engineers is a sophisticated internal or external waterlock system. The concept is that the builders could have constructed watertight, zigzagging channels or conduits up the side of the pyramid. By using a principle similar to a canal lock, they could have floated the stone blocks on barges within these channels. By systematically filling and draining different sections with water from the Nile-fed canals below, they could have raised the barges and their colossal cargo step by step up the side of the structure. The buoyant force of water would do the vast majority of the work, neutralizing the crushing weight of the stone and requiring only a fraction of the human labor needed for ramp-based dragging. While this remains a theory, it is grounded in the known hydraulic capabilities of the Egyptians. It presents a vision of the Giza plateau not as a dry, dusty construction site, but as a dynamic, water-filled landscape where the life-giving Nile was harnessed not just to feed the people, but to literally build their everlasting monuments. This seamless integration of hydraulic science with architectural ambition showcases a level of holistic engineering genius that we are only just beginning to appreciate. This same drive to achieve permanence, to defy the natural cycles of decay, finds its most intimate and chemically sophisticated expression not in stone, but in the human body itself. Our 21st piece of evidence moves from the grand scale of pyramids and temples to the quiet, sacred space of the embalmer's workshop, where we uncover a lost art that was, in truth, a highly advanced form of biochemical technology. The mummification of the dead was far more than a religious ritual. It was a controlled, scientific process that required a profound and systematic understanding of chemistry, one that allowed the ancient Egyptians to preserve soft tissue for thousands of years in a way that modern science still finds remarkably effective. At the heart of this process was the use of natron, a naturally occurring mixture of salts found in dry lake beds, primarily consisting of sodium carbonate, sodium bicarbonate, sodium chloride, and sodium sulfate. This wasn't just a single substance they stumbled upon. It was a specific, complex compound chosen for its unique and powerful properties. The embalmers didn't simply dump this salt on the body. They followed a meticulous, multi-stage procedure. After removing the internal organs, the body cavity was rinsed with palm wine, which acted as a natural antiseptic, killing bacteria. Then the body was packed inside and out with neat, dry natron crystals. This was not a quick brine bath. The body was left to dehydrate in the natron for a period of 40 days. The brilliance of natron lies in its dual action. The sodium carbonate and bicarbonate create a highly alkaline environment, which is profoundly hostile to the bacteria and enzymes that cause decomposition. Simultaneously, the salts act as a powerful desiccant, pulling all the moisture out of the tissues through osmosis, effectively freeze-drying the body from the inside out. The precision in this timing is critical. Too short a period and moisture remains, leading to rot. Too long, and the tissues become overly brittle and shatter. They had clearly calibrated this process through generations of careful observation and refinement. Once the body was fully desiccated, the natron was removed and the final transformative stage began. The dried corpse was then anointed with a complex mixture of resins and oils. This was not merely a symbolic anointing, it was a second layer of chemical defense. Coniferous resins like pine and cedar were heated and applied. These resins are rich in natural biocides and antioxidants, which would have sealed the tissues, creating a protective, plastic-like coating that further barred moisture and microbes. Modern chemical analysis of mummy wrappings has identified a plethora of complex organic compounds, including beeswax, plant gums, and bitumen, each chosen for its specific preservative, waterproofing, or aromatic qualities. In some cases, the chemical reactions between these resins and the body's own lipids created a soap-like substance known as adiposa, a form of natural saponification that added another layer of preservation. The famous blackened appearance of many mummies is not decay, but often the result of this resinous mixture darkening over millennia. This entire procedure reveals a startling depth of practical chemical knowledge. The ancient embalmers were, in effect, master chemists. They understood the antiseptic power of alcohol in the palm wine rinse. They mastered the principles of desiccation and osmosis with natron. They harnessed the polymerizing and sealing properties of heated resins. This was not a static tradition. It evolved over centuries, with different dynasties experimenting with and refining the recipes, indicating a continuous process of scientific experimentation. They were manipulating organic chemistry on a fundamental level to achieve a specific, long-term result. The success of their technology is undeniable, proven by the survival of recognizable human features, skin, and hair on individuals who lived over 4,000 years ago. When we look at a mummy, we are not just looking at a religious artifact. We are looking at the end product of a sophisticated, systematic science, a testament to a civilization that had unlocked the secrets of preservation through a deep, empirical understanding of the natural world's chemical building blocks. Returning now to those enigmatic pre-dynastic stone vases we discussed earlier, we find that their mystery deepens dramatically when we shift our focus from their breathtaking forms to the microscopic world of their surfaces. It's here, in the subtle traces left by the tools that shaped them, that we uncover our 22nd piece of evidence, one that points directly to the existence of a machine that simply should not have existed. While many of these vases are flawlessly polished, others retain faint, ghost-like markings that serve as a frozen-in-time blueprint of their creation. The most telling of these are the unmistakable signatures of a lathe. On the bases and sometimes on the inner shoulders of these vessels, you can find delicate concentric rings, perfectly circular grooves that run parallel to each other around a central point. These are not decorative etchings, they are the residual chatter marks from a cutting tool as it met the spinning stone. Think of a modern potter's wheel or a machinist's lathe. As the workpiece rotates at high speed, a fixed tool is brought to bear against it, shaving away material. Any tiny, imperceptible vibration in the system, or a minute inconsistency in the stone's density, causes the tool to bounce microscopically, leaving behind this telltale pattern of rings. This phenomenon is impossible to create with hand-held tools. You cannot produce perfect concentric circles by manually chipping or grinding. The human hand is incapable of that level of rotational consistency. These rings are the fossilized evidence of a rotating spindle and a fixed cutting head, the fundamental components of a lathe. Then there is the pivot point itself. On the bottom of many vases, particularly those with a rounded or pointed base, you can often find a small, precisely drilled dimple or a raised nub right at the very center. This is the technical heart of the operation. In a lathe, the workpiece must be secured between 2 points, the headstock which provides the rotation and the tailstock which supports the other end. The central dimple on a vase is the ancient equivalent of a live center mark, the exact spot where the tailstock's pin pressed into the stone to hold it steady under immense rotational force. The presence of this deliberate, central point of contact is arguably one of the most damning pieces of evidence against purely manual methods. It reveals a mechanical process where the stone was mounted and centered with extreme care before the cutting even began. Now, let's fully absorb what the existence of a stone-turning lathe implies for our understanding of ancient technology. We are not talking about a simple, bow-driven device for woodworking. To turn a block of schist, diorite, or rock crystal materials far harder than steel, you need a machine of tremendous stability and power. The lathe's frame would have to be incredibly rigid to prevent flex and vibration, which would otherwise shatter the brittle stone. The spindle and bearings would need to be engineered to near-perfect precision to maintain a true, unwavering rotation at high speeds. Most critically, the cutting tool itself presents an almost paradoxical challenge. What material could the cutting tip have been made from that was hard enough to shave diorite without instantly blunting? Copper or bronze would be useless. This strongly implies the use of tipped tools, perhaps embedded with diamonds or another super-hard abrasive like corundum, effectively creating an ancient version of a diamond-tipped cutting bit. The entire apparatus speaks to a workshop environment that was far more akin to a precision engineering lab than a simple artisan's shed. This single piece of technology, the mechanical lathe, would completely revolutionize our view of ancient manufacturing capabilities. It transforms their achievement from one of immense patience and skill into one of systematic, industrial-grade production. With a lathe, creating multiple, identical vessels becomes a straightforward process of replication, explaining the remarkable consistency seen across many artifacts. It provides the only coherent explanation for the flawless symmetry, the impossibly thin walls, and the complex internal contours that defy hand carving. The implications ripple outward, forcing us to reconsider everything. If they had the lathe, what other machinery did they possess? Did they have advanced drill presses, milling machines, or polishing wheels? The stone vase becomes more than a beautiful artifact. It becomes a key that unlocks a door to a forgotten industrial reality, a world where the whirring sound of precision machinery was part of the soundtrack of a civilization we are only just beginning to truly comprehend. Now, as we've journeyed through the monumental stonework and the potential for lost machinery, a fundamental question arises. What was the intellectual framework that enabled such precision? We've seen the mathematical constants embedded in the Great Pyramid and the geometric ratios encoded in the temples, but did this knowledge exist only as an esoteric tradition, or was it systematically documented? The answer lies in two of the most remarkable surviving texts from ancient Egypt, the Rhind and Moscow mathematical papyri. Far from being simple accounting ledgers, these documents reveal a sophisticated, theoretical grasp of mathematics that provided the essential blueprint for their architectural miracles. Let's first open the Rhind papyrus, a scroll dating from around 1550 BC, though it claims to be a copy of an even older text from 2 centuries prior. At a glance, it contains what you might expect: tables for fractions, problems about distributing bread and beer. But nestled within these practical exercises are intellectual leaps that are nothing short of breathtaking. One of its most famous problems demonstrates how to calculate the volume of a truncated pyramid, what we call a frustum. This isn't a simple measurement. It's a complex geometric formula involving the base length, the top length, and the height. The scribe Ahmes provides a step-by-step method that is algebraically equivalent to the modern formula V equals h/3, a 2 plus ab plus b2. To have derived this relationship without the symbolic language of algebra, relying purely on verbal instructions and geometric intuition, reveals a mind capable of extraordinary abstraction. This wasn't just about figuring out how much grain would fit in a silo. This was the precise kind of calculation needed to determine the volume of stone required for a pyramid's ascending courses or the earth needed for a massive ramp. It transforms their architecture from monumental guesswork into a project of precise, calculated engineering. The Moscow mathematical papyrus, slightly older and perhaps even more profound, contains a gem that stuns historians of science. Problem number 10 in this papyrus presents a method for calculating the surface area of what is described as a basket. But the given dimensions and the specific procedure used have led many scholars to a startling conclusion. This basket is actually a hemisphere. The solution provided uses a formula that accurately computes the area, deriving a value for pi in the process. Think about the implications of this for a moment. Over 1,000 years before the Greek mathematician Archimedes would formally work out the geometry of the sphere, an Egyptian scribe was successfully solving problems involving curved, three-dimensional surfaces. This represents a move beyond simple land measurement and into the realm of theoretical geometry. It shows they were contemplating and solving problems of form and space that directly related to the domed structures, the curved surfaces of pillars, and the complex geometry inherent in their art and architecture. What makes these papyri so critical to our investigation is that they bridge the gap between the abstract and the tangible. We can now look at a perfectly curved, bowl-like offering vessel carved from diorite or the complex, segmented architecture of a temple column and see not just artistry but applied mathematics. The theoretical knowledge to calculate these forms existed. The craftsmen who executed these designs were likely working from templates and formulas passed down from a priestly or scribal class that possessed this advanced geometric understanding. The papyri are the surviving paper trail of a vast and systematic knowledge system. They show that the perfection we observe in stone was first achieved in the mind through a rigorous and developed mathematical science. This wasn't a culture that just happened to build precisely. They built precisely because they had the intellectual tools to do so. Yet, there remains a fascinating and telling disconnect. The problems in these papyri are presented as practical challenges for a scribe: how to divide goods, how to measure fields. The most advanced theoretical concepts, like the volume of a frustum or the area of a hemisphere, are framed as clever solutions to seemingly mundane problems. There are no surviving texts that explicitly say, "This is the formula we used to design the king's chamber." This suggests that these papyri were essentially textbooks for training the administrative class. The true, deepest levels of architectural and geometric knowledge, the master plans for the pyramids and temples, were likely considered sacred, protected information, guarded within the closed guilds of master builders and the inner circles of the priesthood. The Rhind and Moscow papyri, therefore, are like a glimpse into the undergraduate curriculum. They prove the civilization was mathematically literate at a high level, hinting that the postgraduate knowledge, the stuff used to build wonders, was even more profound. They are the surviving echoes of a scientific mindset that used numbers not just to count, but to conquer the physical world and shape it into a legacy of eternal stone. Now, as we survey this landscape of ancient wonders, a compelling question naturally emerges. If such advanced stoneworking knowledge did exist in the distant past, did it vanish completely, or were its principles rediscovered in more recent times? This brings us to one of the most fascinating and personal mysteries of the 20th century, a story that serves as a powerful parallel to the enigmas of ancient Egypt. Our 24th piece of evidence is not found in the sands of Giza, but in the heat of Florida at a place called Coral Castle. This incredible complex was the life's work of a single, unassuming man named Edward Leedskalnin, a 5-foot-tall, 100-pound immigrant from Latvia. Between 1923 and 1951, working almost entirely alone and mostly under the cover of night, Leedskalnin single-handedly quarried, sculpted, transported, and erected over 1,100 tons of oolitic limestone. The blocks he moved are not small. They include a towering obelisk weighing 28 tons, a 9-ton swinging gate so perfectly balanced a child can push it open, and massive stone chairs and tables each weighing multiple tons. The methods Leedskalnin employed remain as much a mystery as those of the ancient builders. He was notoriously secretive, shrouding his work area with tarps and refusing to allow anyone to watch him. When pressed, he would only offer a cryptic explanation. He claimed to have rediscovered the building secrets of the pyramids. He spoke of understanding the laws of weight and leverage and of harnessing the perpetual motion holder. He asserted that the ancient Egyptians, along with the builders of ancient civilizations across the Americas, were not primitive, but were instead masters of a fundamental energy that modern science had overlooked. He famously stated, "I have discovered the secrets of the pyramids. I have found out how the Egyptians and the ancient builders in Peru, Yucatan, and Asia, with only primitive tools, raised and set in place blocks of stone weighing many tons." For Leedskalnin, this was not a theory. It was a practical reality he demonstrated through his own incredible achievements. So, how did he actually do it? When questioned about moving a 9-ton block, he would simply say he understood the principles of leverage. Mainstream explanations suggest he used simple tools, block and tackle systems, chains, winches, and tripods made from old telephone poles. He was a clever inventor and reportedly used the parts from an old Ford Model T to create a makeshift generator and a primitive winch. While this accounts for some mechanical advantage, it fails to fully satisfy the immense logistical challenges. Eyewitness accounts from the few delivery drivers who brought him supplies describe seeing the massive stones already moved when they returned, with Leedskalnin working alone. The sheer speed and efficiency with which he worked without the aid of cranes or modern heavy machinery continues to baffle engineers and physicists. How does one man, with simple hand tools, position a 28-ton obelisk perfectly upright into its socket using nothing but a tripod and a chain hoist? The physics of controlling such immense weight with such basic equipment is a puzzle in itself. This is where Leedskalnin's story transcends a mere modern curiosity and becomes profoundly relevant to our investigation of ancient technology. His achievement stands as a living, modern proof of concept. It demonstrates that it is physically and logistically possible for a single individual, without access to advanced contemporary machinery, to manipulate multi-ton stones with stunning precision, provided they possess a specific, perhaps forgotten, body of knowledge. If one man in the 1940s could allegedly uncover and apply a lost method, it powerfully reinforces the possibility that such methods were known and widely utilized in antiquity by entire civilizations. Leedskalnin becomes a critical case study. He acts as a bridge connecting the seemingly impossible feats of the ancient world with a tangible, modern example of what could be achieved. His work suggests that the gap between primitive tools and monumental construction might not be bridged by vast armies, but by a sophisticated understanding of physics, an understanding that we in the modern era, for all our technological prowess, may have somehow misplaced. The true lesson of Coral Castle is not that we need to believe in magic or alien intervention. Rather, it forces us to acknowledge that human ingenuity can find solutions that lie outside the mainstream of scientific thought. Edward Leedskalnin claimed he was using the same principles as the pyramid builders. Whether he was entirely correct or not is almost secondary. His enduring legacy is that he proved in stone that our conventional narrative of how massive structures must be built is incomplete. He showed that the secrets of the ancients might not be locked away in lost libraries, but could be rediscovered through observation, experimentation, and a radical rethinking of the fundamental relationship between mass, energy, and leverage. His solitary, monumental struggle in the Florida wilderness echoes the silent challenge of the Serapeum and the unfinished obelisk, reminding us that the past may hold secrets of practical science just waiting for a curious mind to find them again. Now we arrive at one of the most viral and hotly debated images to emerge from ancient Egypt, our 25th piece of evidence, the so-called Abydos helicopter. Tucked away within the Temple of Seti I at Abydos, a location we've already visited for its profound mysteries, is a small but explosive panel of hieroglyphs. To the modern eye, the carvings are startlingly anachronistic. Alongside more traditional symbols, you can clearly make out shapes that look like a helicopter, a submarine, a futuristic aircraft, and even what some describe as a hovercraft or a zeppelin. It's an image that seems to tear a hole in the fabric of history, and it has become a cornerstone of popular speculation about premonition or even time travel. But is this truly a prophetic blueprint from the past, or is there a more grounded, albeit equally fascinating, explanation? The mainstream archaeological explanation for these bizarre shapes is a process known as palimpsest. This term, borrowed from manuscript studies, describes a surface that has been reused, where the original writing or carving has been altered but traces of the earlier version remain. In the case of the Abydos temple, the story is one of royal succession and practical renovation. The temple was originally commissioned by Pharaoh Seti I, and the walls were inscribed with his royal cartouches and standard hieroglyphic text. After his death, his son, the great Ramesses II, took the throne. In a common practice to solidify his own legacy, Ramesses had workmen recarve some of his father's inscriptions, effectively plastering over Seti's names and titles and replacing them with his own. Over centuries, this thin layer of plaster filler has eroded and fallen away. What we are left with is a composite image, a ghostly amalgamation where parts of the older, underlying Seti cartouche and parts of the newer, overlying Ramesses cartouche are visible at the same time. The seemingly modern machines are, according to Egyptologists, nothing more than the accidental and overlapping shapes of these two sets of hieroglyphs. Let's break down this process with a specific example. The famous helicopter shape is largely formed by the interaction of two key elements. The main body and rotors come from the recarving of a particularly intricate title of Seti I. The original carving might have included a repeated serek, a palace facade motif, and the glyph for a bird, perhaps a goose. When the plaster was applied and Ramesses' craftsmen began their work, they carved their own set of symbols directly on top. Their new glyphs, intended to spell out one of Ramesses' own names, interacted with the faint, remaining contours of the older glyphs beneath the plaster. The curved tail of the helicopter might be the remnant of a staff or a scepter from the original text, while the cockpit area could be a reshaped ankh symbol or a loop from a cartouche. The human brain, especially one conditioned by a modern technological world, is exceptionally good at finding familiar patterns in random shapes, a phenomenon known as pareidolia, where we see faces in clouds or animals in rock formations. The Abydos panel is a perfect storm for this tendency, where the complex, overlapping lines of legitimate hieroglyphs from two different eras coalesce into forms that our 21st century minds immediately interpret as advanced machinery. However, the alternative viewpoint argues that this official explanation, while logical, doesn't entirely resolve all the questions. Skeptics of the palimpsest theory point to the sheer visual coherence of the machines. The helicopter, for instance, isn't just a vague, jumbled mess of lines. It has a distinct and well-defined silhouette, complete with a cockpit, a tail boom, and what appear to be rotor blades. The other objects in the panel are similarly well-formed. Could a random overlap of two different sets of symbols really produce such clean, recognizable, and distinctly mechanical-looking shapes by pure chance alone? The precision of the overlap feels, to some, suspiciously perfect. This has led to a persistent counter-narrative that these carvings are evidence of something far more extraordinary. The theories range from the idea that the ancient Egyptians had witnessed advanced technology, perhaps from a lost civilization, and were attempting to record it, to the more esoteric suggestion that the carvings represent a form of prophetic vision, a glimpse into a future that the carvers themselves did not fully understand. The enduring power of the Abydos helicopter in popular culture speaks to a deeper human desire to find connections across time and to challenge the official story. It serves as a powerful Rorschach test. A mainstream Egyptologist looks at the panel and sees a clear, documented case of historical revisionism and natural erosion. A proponent of alternative history looks at the very same stone and sees a deliberate record of impossible knowledge. This single, weathered wall in Abydos forces us to confront the limits of our interpretation. It reminds us that our understanding of the past is often a fragile reconstruction, and that sometimes the most compelling mysteries are not created by what was intentionally written in stone, but by the beautiful, chaotic, and utterly unpredictable accidents of time. Whether a quirk of geology and politics or a genuine enigma, the Abydos helicopter remains a captivating symbol of the endless debate between orthodox explanation and the tantalizing possibility that our history is far stranger than we have been led to believe. This same signature of impossible stonework, this eerie perfection in joining colossal blocks, is not a story confined to the sands of Egypt. To fully grasp the magnitude of this mystery, we must pull our perspective all the way back to a global scale, because what we find is a pattern, a specific, baffling construction technique that appears in civilizations separated by vast oceans and thousands of miles, yet they all seem to be reading from the same advanced architectural playbook. This brings us to our 26th piece of evidence, the global phenomenon of megalithic polygonal masonry, a building style so distinctive and so complex that its widespread occurrence hints at a knowledge network that challenges our entire understanding of the ancient world. Let's travel across the Atlantic, high into the Andes Mountains of Peru, to the fortress of Sacsayhuaman, which towers over the city of Cusco. The scale here is almost incomprehensible. We are looking at walls constructed from enormous blocks of limestone, some of them weighing well over 100 tons, but the sheer weight is not what stops you in your tracks. It is the insane, almost organic complexity of their assembly. These are not simple, rectangular bricks. The stones are polygonal, meaning they have multiple sides and angles, each one a unique, irregular shape. Yet despite this apparent chaos of forms, they are fitted together with a precision that defies belief. Each block is custom carved to fit perfectly against its neighbors in a giant, three-dimensional stone puzzle. The joints between them are so tight, so seamless, that you cannot slip a piece of paper, or in some cases even a razor blade, between them. This is a wall built without a single drop of mortar, and it has withstood centuries of earthquakes that have reduced later Spanish colonial buildings to rubble. The larger stones at the base, known as the Inca's throne, are behemoths with 12 distinct angles, each angle perfectly matching the contours of the surrounding blocks. How do you achieve such a perfect, interlocking fit with stones of this size and hardness, using only simple tools? Now, hold that image in your mind and let's return to Egypt, to the Osirian at Abydos. We've already discussed its massive foundation stones and perfectly level floor, but its walls tell the same story as Sacsayhuaman. Here too, we find colossal blocks of red granite and sandstone, often weighing 50 to 100 tons, shaped into complex polygonal forms and fitted together with that same uncanny, seamless precision. The joints are tight, the corners are sharp, and the entire structure gives the impression of a single, fused mass of stone rather than a collection of individual blocks. The similarities are not superficial, they are profound. In both Peru and Egypt, we see the same rejection of simple, rectangular construction in favor of this vastly more difficult, more time-consuming, and more technically demanding method. Why would two cultures, supposedly never in contact, both choose the most architecturally challenging path imaginable? This specific technique of polygonal masonry offers immense structural advantages, which these ancient builders clearly understood. A wall made of interlocking, irregular polygons is incredibly resilient. Unlike a wall of rectangular blocks which has straight, continuous mortar lines that can be a point of failure, a polygonal wall has no straight lines of weakness. The complex, zigzagging joints distribute stress and shear forces throughout the entire structure, making it extraordinarily resistant to seismic activity. It acts like a shock absorber, flexing and settling without collapsing. This is why Sacsayhuaman has survived earthquakes for centuries, and it's likely a key reason the Osirian's foundations have remained intact for millennia. This isn't just a stylistic choice, it's a highly sophisticated form of earthquake engineering. The builders in both locations possessed a deep, practical understanding of physics and the behavior of materials under stress, knowledge that we would typically associate with modern structural engineering. So how do we explain this remarkable parallel? Mainstream archaeology offers a straightforward, diffusionist explanation. It's a case of independent invention. This theory posits that different human societies, when faced with similar challenges like building stable, monumental structures in earthquake-prone regions, can independently arrive at similar solutions. The human mind, reasoning logically about stability and weight, could theoretically invent polygonal masonry in isolation. It's a plausible and academically accepted viewpoint that emphasizes the universal ingenuity of humanity. However, the alternative perspective asks a more provocative question. Could the similarities be too specific, too technically advanced to be mere coincidence? We are not talking about a simple concept like a pyramid, which is a relatively stable shape that many cultures could conceive of independently. We are talking about a specific, highly complex methodology, the quarrying of 100-ton stones, the ability to shape them into intricate polygonal forms with micrometer precision, the technique for dry fitting them to create seamless joints, and the engineering knowledge to understand their superior seismic performance. This is a complete package of advanced skills. The possibility arises that we are not looking at independent invention, but at the scattered remnants of a shared, archaic knowledge system, a kind of foundational school of construction that was once global, but whose origins have been lost to time. This doesn't necessarily mean a single, globe-trotting civilization, but perhaps a common source of knowledge that different cultures accessed, adapted, and then forgot. The implications of this are staggering. It suggests that long before the dawn of what we recognize as recorded history, there may have been an epoch of profound technological and scientific advancement. A period when humanity, or at least a core group of master builders, possessed a unified understanding of stone, geometry, and physics. This knowledge could have been carried across the world by ancient mariners or preserved by a dedicated priesthood of architects, only to fragment and fade as civilizations rose and fell. The polygonal walls of Sacsayhuaman and the Osirian then become more than just isolated marvels. They become surviving fragments of a lost global legacy. They are the durable, stone-hard evidence that the ancient world was far more interconnected, or at least far more uniformly advanced than our history books have ever dared to suggest. These silent, interlocking stones stand on opposite sides of the planet, whispering the same secret that a chapter of human achievement is missing from our story, and its fingerprints are etched into the most enduring monuments we have ever found. And now we turn from the silent testimony of stone to a document drawn on parchment, a map that has sparked one of the most enduring geographical controversies of the modern era. Our 27th piece of evidence is the Piri Reis map of 1513. Discovered in the Topkapi Palace in Istanbul in 1929, this fragment of a larger world chart was drawn by the Ottoman admiral and cartographer Piri Reis. He himself wrote notes on the map explaining that he compiled it from a score of different source maps, some of which he described as dating back to the time of Alexander the Great. It's a beautiful and detailed artifact of 16th century Ottoman cartography, but its true mystery lies in a single, startling feature: the apparent depiction of the coastline of Antarctica, a continent that wouldn't be officially discovered for another 300 years, and one that has been buried under a mile of ice for millennia. The section of the map in question shows a landmass stretching northward from the southern Atlantic. What makes this landmass so astonishing is its shape and the details of its coastline. When modern seismographic surveys conducted in the mid-20th century finally mapped the subglacial topography of Antarctica, the correspondence was uncanny. The Peary Rise map seems to show the Queen Maud Land coastline and, even more incredibly, features that align with the subsurface landforms beneath the ice sheet, including bays, peninsulas, and mountain ranges that are completely invisible to the naked eye. The implication is staggering. The source maps used by Peary Rise must have been created by a civilization that charted Antarctica at a time when its coasts were ice-free and accessible. Given our current understanding of climate history, the last time the coast of Antarctica was in such a state was over 6,000 years ago, in a pre-glacial epoch long before the rise of any known seafaring culture capable of such a global surveying effort. Mainstream skepticism offers a series of counter-arguments, attempting to ground this incredible claim in more conventional history. One prominent theory is that the controversial landmass isn't Antarctica at all, but a speculative, composite representation of the southern coast of South America, perhaps distorted by the mapmaker's lack of accurate longitudinal measurements. Cartographers of the era often filled unknown southern regions with hypothetical land, a convention known as terra australis incognita. Furthermore, critics point out that the map is missing vast stretches of coastline that would be essential for a truly accurate depiction of the frozen continent. They argue that the apparent similarities are a classic case of pareidolia, our brain's tendency to see meaningful patterns in random shapes, and that we are simply projecting our modern knowledge of Antarctica's shape onto an old, imperfect map. However, this conventional explanation struggles with the specific, non-random nature of the coastal details. The fit between the Peary Rise outline and the subglacial surveys is geometrically too close to be easily dismissed as pure coincidence or artistic license. If it is a distorted South America, why does its western portion so closely mirror a different, unknown coastline thousands of miles away? This paradox leads to a fascinating and profound possibility. The source maps cited by Peary Rise may have been the legacy of a truly ancient, advanced maritime civilization, a culture with the shipbuilding technology and navigational skill to undertake a global mapping project. This wouldn't necessarily be a single, mythical empire like Atlantis, but perhaps a network of seafaring peoples whose knowledge was preserved in the great libraries of the ancient world, like the Library of Alexandria. When that repository was destroyed, its geographical knowledge might have survived in scattered copies, which eventually found their way into the hands of later cartographers like Peary Rise. The technical implications of such a source map are as bewildering as the pyramids themselves. To create a map that accurately represents a coastline, one needs more than just a ship's log. It requires a sophisticated understanding of spherical trigonometry to project the curved surface of the Earth onto a flat plane. The Peary Rise map utilizes a sophisticated cartographic projection, centering on a point in Egypt, which suggests its source material was the product of a centralized scientific survey. The level of mathematical and astronomical knowledge required for such an undertaking is immense. It implies that this hypothetical precursor civilization possessed not only advanced ships, but also a precise knowledge of longitude, a problem that would stump European navigators for centuries longer. The map, therefore, becomes more than just a curious anomaly. It transforms into a potential piece of a lost global puzzle, a surviving whisper from an age of exploration that predates our own by thousands of years, suggesting that the oceans were crossed and the world was mapped in an epoch now shrouded in the mists of deep time. This brings us to a different kind of evidence, one that isn't found in a single, perfect artifact, but is instead embedded in the overwhelming, repetitive nature of the work itself. Our 28th piece of evidence is the sheer, staggering volume of production. When we step back from the individual masterpiece and look at the collective output, we see a pattern that points unmistakably toward an industrial, rather than a purely artisanal mindset. This is most vividly illustrated by the Great Pyramid alone, which is composed of approximately 2.3 million individual blocks. While the outer casing stones and the internal granite chambers show the highest precision, the vast majority of these blocks are the core limestone blocks. And here's the critical point: these millions of core blocks are not random, irregular hunks of stone. They are remarkably consistent in size and shape, forming a standardized modular system. Consider the logistical implications of this. To build the pyramid within a plausible time frame, say 20 to 30 years, the builders would have needed to quarry, shape, transport, and set an average of one block every 2 to 3 minutes of every single working day. Now, imagine achieving that pace using only teams of workers with copper chisels and stone hammers. Each block would be a unique project, with workers slowly pounding it into a roughly rectangular shape. The variation between blocks would be enormous. No two would be exactly alike, and the fitting process would be a constant, time-consuming struggle to make irregular pieces lock together. Yet the pyramids stand as a testament to a high degree of uniformity. This consistency is the hallmark of a standardized process. It suggests the use of templates, jigs, or guided cutting systems that could produce a repeatable product quickly and efficiently. It's the difference between a blacksmith painstakingly forging one unique sword at a time and a factory using molds and presses to produce thousands of identical blades. The scale and uniformity of the pyramid's core masonry point toward a system that had more in common with the factory than the forge. This evidence of mass production becomes even more compelling when we return to those enigmatic pre-dynastic stone vases. We've already marveled at their impossible symmetry and lathe-like finish, but their true significance multiplies when we consider their numbers. Thousands of these vases have been recovered from sites like Saqqara, and what is truly astounding is how many of them are virtual duplicates of one another. You can find multiple vases with the exact same profile, the same delicate, flared lip, the same slender neck, and the same spherical body, all carved from the same unforgiving material like diorite or basalt. To create one of these vases by hand would be the life's work of a master artisan. To create thousands of near-identical copies is something else entirely. This level of replication defies the very nature of artisanal craftsmanship. In a handmade process, even the most skilled craftsperson will introduce minor variations: a slightly different curve, a marginally thinner wall, a unique pattern of tool marks. These small imperfections are the signature of the human hand. The breathtaking consistency across so many of these vases, however, suggests that human variability was systematically removed from the equation. This is the fingerprint of a fixed manufacturing process. It implies the use of a technology that could replicate a design with machine-like perfection over and over again. Think of a modern assembly line where a master mold is used to create thousands of identical plastic parts. The ancient vase makers appear to have had an analogous system, but for stone. They had mastered a method of production that could output a standardized, high-precision product in quantities that satisfy the definition of mass production. The vases are not individual works of art, they are units of output from a sophisticated and highly organized manufacturing tradition. So, how does this reconcile with the official toolkit of copper and stone? The uncomfortable truth is that it doesn't. The concept of mass production is intrinsically linked to efficiency and the minimization of labor per unit. The traditional methods attributed to the ancient Egyptians are the absolute antithesis of efficiency. Manually pounding a granite block into shape with dolerite stones is a slow, labor-intensive, and wasteful process. Manually grinding the interior of a diorite vase using sand and a stick is a task that could take a lifetime. To achieve the volumes we observe, the workforce would have needed to be unimaginably vast, and the material waste, the shattered stones, the worn-out tools, the piles of stone dust would have left a colossal archaeological footprint that we simply do not see. The absence of this expected industrial waste is in itself a powerful piece of negative evidence. The inescapable conclusion is that the ancient builders possessed a production technology that was both highly efficient and remarkably clean. They had developed methods that allowed them to work hard stone quickly, precisely, and with minimal waste. Whether this was through the use of advanced alloy tools, powerful machinery, or even a lost chemical or sonic process that softened the stone, the output speaks for itself. The millions of nearly identical pyramid blocks and the thousands of mirrored vases stand as a silent, collective testimony to a society that had industrialized stoneworking. They moved beyond the realm of the individual craftsman and entered the age of mass production, a feat that would not be seen again on such a scale for thousands of years, forcing us to completely reimagine the sounds and sights of their workshops, which may have hummed with an efficiency we would find strikingly modern. Now, as we've journeyed through the visual and tactile evidence, the machined stone, the encoded mathematics, the colossal logistics, we must turn our attention to a dimension of this mystery that we can't see, but can only hear and feel. Our 29th piece of evidence moves beyond the physical into the vibrational, into the very soundscape of these ancient places. This is the emerging science of archaeoacoustics, the study of sound within archaeological sites, and what it's revealing suggests the ancient builders were not just masters of stone and sky, but also of sonic engineering. Consider the experience of standing in the Grand Gallery inside the Great Pyramid. It's not just a corridor, it's a soaring, narrow, corbel-vaulted hall that angles steeply upward into the heart of the monument. For centuries, it was seen as nothing more than a majestic passageway, but when researchers began to analyze its acoustic properties, they discovered something extraordinary. The Grand Gallery acts as a giant resonant cavity, a massive sound amplifier. Specific frequencies, particularly those in the lower ranges, are not just amplified here, they are sustained. A single note, like a deep chant or the sound of a ritual drum, would resonate and linger, filling the entire space with a powerful, vibrating hum that seems to come from the stones themselves. This isn't a minor acoustic effect, it's a deliberate sonic phenomenon. The precise angles, the smooth, sloping limestone walls, and the specific dimensions of the gallery all conspire to create this resonant environment. To achieve this by accident in a structure of such geometric complexity seems statistically impossible. It points to an intentional design, an architecture of sound. This phenomenon isn't isolated to the Great Pyramid. In subterranean chambers like the Hypogeum on Malta, a site thousands of years old, certain niches and rooms are tuned to specific resonant frequencies, often right around 110 Hz. This is a profound sonic sweet spot. Modern neurological studies have shown that exposure to frequencies in this range can directly alter brain activity. It can shift patterns in the prefrontal cortex, temporarily quieting our language centers and potentially heightening states of meditation, focus, or even transcendence. Imagine the impact during an initiation ceremony. A priest or shaman's voice chanting at this specific frequency within a chamber designed to amplify it would have a tangible, physiological effect on everyone present. It wouldn't just be a spiritual suggestion, it would be a sonic technology directly influencing brain function, guiding participants into an altered state of consciousness conducive to receiving visions or divine messages. This transforms these chambers from passive ritual spaces into active, psychotronic instruments. So, what could have been the purpose of such sophisticated acoustic design? One of the most compelling theories is that these spaces were used for healing. The concept of using sound and vibration for therapeutic purposes is ancient and is seeing a major resurgence today in modern medicine. Could the builders have understood that specific resonant frequencies could promote cellular regeneration, reduce pain, or alter consciousness for healing? The prolonged, resonant hum in the Grand Gallery could have been used to create a giant sonic bath where the entire body is immersed in a healing vibrational field. Another, more technological theory ventures into the realm of the truly extraordinary. Some researchers, like inventor and author John Ernst Worrell Keeley, have proposed that specific sonic frequencies, when combined with certain geometric shapes, can influence matter and energy in ways we are only beginning to grasp. This gets into the speculative territory of acoustic levitation. Could the resonant frequencies within these chambers have been used to somehow counteract gravity, making the immense stone blocks used in construction easier to move? While this remains firmly in the realm of theory, it's a concept that finds echoes in various ancient traditions and modern physics experiments exploring the manipulation of matter with sound waves. Of course, mainstream archaeology often approaches these ideas with understandable caution. The counter-argument is that these acoustic properties are simply a fortunate or unfortunate byproduct of the architectural forms needed for structural stability. A large, smooth, enclosed space made of hard stone will naturally have resonant characteristics. The builders, this view suggests, were focused on creating a stable, monumental tomb, not a concert hall. They may have noticed the acoustic effects and incorporated them into their rituals, but the idea that they engineered it from the ground up is considered an overinterpretation. However, this skeptical view struggles to explain the sheer consistency and power of the acoustic effects across so many disparate ancient sites, from the pyramids of Egypt to the underground temples of Malta and the circular stone chambers of the Americas. The repetition of this phenomenon across cultures and continents suggests it was more than just a happy accident. It was a recognized and sought-after principle. The true significance of archaeoacoustics is that it adds a completely new layer to our understanding of ancient genius. It shows us that their mastery was holistic. They weren't just building structures to be seen, they were crafting environments to be experienced with the entire human sensorium. They understood that sound is a physical force, a vibration that can shape consciousness, influence biology, and perhaps even interact with the fabric of reality in ways we are only now rediscovering. The silent stones of these ancient sites are not so silent after all. They hold a captured resonance, a frozen song waiting for the right conditions to be heard again, reminding us that the greatest secrets of the past may not be written in hieroglyphs, but encoded in the very vibrations of the air itself. And so we arrive at our final, 30th piece of evidence, a clue that comes not from a quarry or a temple wall, but from a text, a document so ancient and so fantastical that it challenges our perception of history itself. This is the Sumerian king list, a cuneiform tablet that records the rulers of Sumer, a civilization in ancient Mesopotamia that predates even dynastic Egypt. On its surface, it begins as a straightforward historical record, but it quickly spirals into the realm of the unbelievable. It states that after kingship descended from the heavens, the first rulers reigned for periods that are simply incomprehensible. We are told of kings like Alulim, who ruled for 28,800 years, and Alaljar, who governed for 36,000 years. These are not minor exaggerations. These are spans of time that dwarf all of recorded human history. The mainstream academic interpretation is understandably that these immense figures are purely mythological. They are seen as a literary device, a way for the Sumerians to express the concept of a primordial, sacred time, a golden age when gods walked the earth and their semi-divine representatives held sway for vast cosmic cycles. The reigns are symbolic, not literal, meant to separate the era of the gods from the era of men, with the numbers gradually decreasing until they reach the more historically plausible reigns of later kings. This is a perfectly rational reading, one that aligns with how many ancient cultures mythologized their own origins. However, an alternative perspective asks a compelling question. What if this mythology is not pure invention but a heavily distorted memory? Could these staggering numbers be the echo of a real, much older civilization, one so technologically and biologically advanced that its achievements and the lifespans of its leaders became indistinguishable from divinity in the eyes of their less developed successors? Imagine a cataclysm, a great flood, a climatic shift that virtually wiped out this advanced precursor culture. The few survivors, or the cultures that arose from the ashes, would have possessed only fragmented knowledge of the world that came before. The stories they told would be a mixture of awe-struck remembrance and imaginative filling in of the blanks. The advanced technology of the gods would be described as magic. Their longer, healthier lives, perhaps achieved through a mastery of genetics or medicine we can scarcely imagine, would be recorded as reigns of tens of thousands of years. Their sophisticated machines and energy sources would become the fiery chariots and magical stones of legend. This theory creates a powerful, unifying context for the mysteries we've explored throughout this journey. The inexplicable precision of the Giza pyramids, the machined stone boxes of the Serapeum, the advanced mathematical knowledge encoded in the temples, all of it could be the physical legacy of this hypothetical precursor civilization. The Egyptians, the Sumerians, and perhaps even the builders of distant sites like Pumapunku would not be the originators of this high technology, but its inheritors. They would be the cultures that found the ruins of a grander age and did their best to replicate its glory, often without fully understanding the science behind it. The Sumerian king list, then, is not just a fanciful story. It becomes a potential piece of historical testimony, a garbled, poetic record of a time when humanity, or a branch of it, reached a peak of achievement so high that its collapse sent ripples through millennia, leaving behind only the most durable of its creations and the most persistent of its legends, whispered in king lists and carved in impossible stone. This final piece of evidence ties all the others together, suggesting that the true mystery of our past is not just about how they built these wonders, but about who they were really building upon. And so we stand at the end of this journey, looking back across a landscape of mysteries that stretches from the Great Pyramid to the Andes, from the lathe-turned vases of pre-dynastic Egypt to the resonant chambers of Malta. We have examined 30 distinct pieces of evidence, each one a thread in a tapestry far more complex and wondrous than the one presented in our standard history books. Consider the sheer, overwhelming weight of it all. It begins with impossible precision, the Great Pyramid's alignment to true north within a fraction of a degree, the granite boxes of the Serapeum with their flawless, machined surfaces that defy the capabilities of copper tools. It continues with anomalous artifacts like the Baghdad Battery and the core sample UC-16000, whose spiral groove tells a silent story of powered, mechanical drills biting into stone thousands of years before such technology was supposed to exist. We have seen sophisticated knowledge encoded in stone and parchment, the golden ratio and Fibonacci sequence woven into temple walls, the advanced geometry of the Rind papyrus solving for the volume of a pyramid frustum, and the celestial map of Giza perfectly mirroring the stars of Orion's belt. We have grappled with logistical miracles, from the movement of 1,000-ton statues to the potential use of geopolymer concrete, and we have encountered the eerie silence of soot-free tombs, suggesting a lost method of illumination. From the water-eroded Sphinx pointing to a climate thousands of years older than its attributed age, to the global phenomenon of polygonal masonry at Sacsayhuaman and the Osirian, the evidence does not merely suggest a few lucky accidents or overachieving primitive cultures. It points with increasing insistence to a profound and systematic anomaly in our understanding of the human past. When examined in isolation, skeptics can, and do, offer conventional explanations for each piece. The dendrolite can be dismissed as a mythological scene, the unfinished obelisk's trenches as the result of relentless pounding, and the Piri Rise map as a cartographic fluke. But the true power of this investigation lies not in any single silver bullet artifact, but in the collective cumulative force of all 30 clues viewed together. It is the pattern that emerges, a consistent, repeating signature of advanced machining, sophisticated mathematics, and a scientific understanding that appears in the archaeological record with a sudden, inexplicable maturity. One anomalous vase could be an outlier. Thousands of them, coupled with the pyramids, the precision-drilled granite, and the acoustic engineering of their sacred spaces, forms a pattern that can no longer be comfortably ignored. This collective body of evidence builds a compelling case that our historical timeline is not just missing a few pages, it may be missing an entire volume. This is not a call to blindly believe in ancient astronauts or Atlantis, but rather an invitation to embrace a more nuanced and open-minded form of inquiry. It is a challenge to the rigid orthodoxy that often dismisses uncomfortable data out of hand. The true spirit of science is not to defend an established narrative, but to follow the evidence wherever it may lead, even if that path leads to uncomfortable questions about the rise and fall of civilizations. The story of humanity is likely far older, more complex, and more incredible than we have ever imagined. These 30 pieces of evidence are not the end of the conversation, they are the beginning. They are an invitation to look at the world with fresh eyes, to question what we have been told, and to wonder what other secrets are still buried, waiting to be rediscovered. The conversation does not end here. This is where you come in. What piece of evidence resonated most powerfully with you? Do you have a theory that connects these dots in a different way? The search for truth is a collaborative effort, and your perspective is a vital part of it. Share your thoughts, your questions, and your own research in the comments below. Let's continue this fascinating discussion together. If you enjoyed this deep dive into the mysteries of our past, please consider subscribing to the channel. There are countless more enigmas to explore, from lost cities to forgotten technologies, and we will be delving into them all. Thank you for watching, for keeping an open mind, and for joining us on this incredible journey to uncover the hidden chapters of our human story.